Hi everyone, and welcome to this chapter. In this chapter of the Flutter State Management course, we're going to talk about Redux. And this is a term that you may have heard before, but you never really got the time to explore Redux before. So in this chapter, we're going to talk about Redux and how you can use it in your Flutter applications to manage your state. So the reasoning behind Redux is documented actually quite extensively. So you can have a look at the reasoning at the link that I've provided in here. But I will give you the gist of it right now. So usually states in applications, regardless of your background, in which programming language or SDK you're working with, it can get quite messy. It can get quite like spaghetti-like in that it leaks throughout your code. There are different parts of your application that are playing with the state, and you may even be playing with the application state from your views, for instance. So Redux tries to clean that up by saying that the state is kind of like global. There's just one state. And then you will, and that state is actually called a store, as we'll talk about it soon. And then you will have functions, pure functions that modify that state based on different actions. So Redux basically is divided into three main important components. One is your application state itself. And then that application state, as you would imagine, it will contain the application's data that represents the state of the application. Then you will have actions, and in here I've written action, but action as a whole. And these actions are kind of like commands that you issue, usually in Flutter applications, at least from your UI. And these commands will then go into sets of something that Redux calls reducers. And these reducers will act upon your actions. And by acting upon your actions, these reducers then create new states. So it's really just like a state machine. So if you think that you have a store and that store keeps hold of your state, then you have so the state is immutable and it's sitting right here. Nobody's mutating this state. Then you will have actions coming in. For instance, a user presses a button. This action comes in. And then you have a set of functions that sit in between here. These actions go into these functions. These functions can then intercept these actions and produce new states and put them back into the store. So it's really a simple concept. However, it can get quite complicated the more you dig into it and the more you use, for instance, the various components that Redux and Flutter Redux provide to you. So in this chapter, we'll break those things down. I'll try to do my best to explain those concepts. So when it comes to the state should and will be an immutable class in Dart. The way that it is defined and the way it is thought about is that state shouldn't be mutated as your application progresses. Instead, your state has to be produced anew, like there needs to be new instances of your state based on the various actions that the user performs. So the state that is right here, there should be no function outside or inside the state that in any way mutates the state. And as you'll soon see, when we start developing these states ourselves, we will actually mark these states as immutable as well in Dart to indicate that there's nothing inside or outside the state class that is going to change it. So now that you have your state, you need to then define your actions. Let's say that you have an application that just has a single button on that user interface, a Flutter application that loads a JSON file. When the user presses this button, this needs to emit an action. And this action could just be a simple load the JSON file. The class name could literally just be called load the JSON file action. And when you send this action, then it defines the request to the store. Remember, the store is kind of like a virtual environment where you hold on to your state. And then you will be able to dispatch actions to that store For reducers, which are pure functions, as we're going to talk about them soon, exactly right after this, actually, the reducers will then be able to take action, or maybe I shouldn't say take action. The reducers are going to be able to react to those actions, and they're going to then be able to produce new states that then get inserted into the store. Now let's talk about these reducers that I mentioned that they are pure functions. So these reducers, they take an old state of the application. It is nothing that you have to do. Instead, the old state will be passed to your reducers by Redux itself. So you will get an old copy of your immutable state, and then you will get the current action that is trying to be performed. Now, if you then decide to actually act upon that action, you will be expected to return a new state. So you should not at all have any side effects inside your reducers that happen in response to an action. What I mean is that if, for instance, that button is tapped and you want to load a JSON file, you shouldn't do that inside your reducer. And a reducer is a function that should be synchronous. It doesn't do any side effects, and it optionally returns a new state. So let's say that you've defined 10 actions in your application, and one of those actions needs to load a JSON file. Now, that action is asynchronous. Therefore, you know that it shouldn't be placed inside a reducer. We will talk about these things soon, but that action needs to be handled inside something called a middleware. And we'll talk about that soon, actually, so don't worry about it. But for now, just know that your reducers should be pure functions in that they take an old state, an action, and then they can optionally return a new state that will be stored in the application store. And again, don't worry, this is a lot of just theoretic or theories right now. So we're just talking about these theories, and it will make a lot more sense when we start actually implementing some applications with Redux soon. As I mentioned, it's very important that whenever it comes to doing asynchronous functions, asynchronous tasks, you shouldn't do them in a reducer. So the reducer should not, in other words, have a side effect. Reducers should only take an old state, the current action being performed, and optionally return a new state. Or if they cannot perform the action, if, for instance, you have 10 reducers, 2 of which cannot handle the current action, they only need to return the old state. That is one of the parameters provided to that reducer, as you'll soon see. So what puts all of this together? So you have the actions, you have the state, and then you have these middleware. Well, what puts it all together is something called a store object. And this store object is kind of like a glue that puts all these components together. So this store is something that you don't manually, you don't have to create a subclass or anything from that. All you really need to do is just to make sure that you create the store by making an API call to Redux itself. And when it comes to the store itself, it is very important that you keep only one store in your entire Redux application. And by that, I mean that you shouldn't have many different stores and many different states in various screens of your Flutter application, for instance. Or if you're creating, for instance, a Flutter web application or Windows application, it doesn't matter. As long as you're working with Flutter and Redux, it is recommended that you only have one store. And that means your application should really only have one state as well. This is just one of the recommendations, and I think we should stick by it. So just be aware of not creating multiple stores in your application. So that was a lot of theory. It was almost about 10 minutes of theory, but I think it's so important to understand the basics before we actually move on to writing an application. I will refer back to these basics as we're writing our examples, so I don't have to explain all these concepts over and over again. Let's go ahead and create a simple Redux application. And in this application, I can actually show you how it looks like, so you get a good idea how it actually works as well. Let me bring the app here, and I'm going to change the screen layout a little bit. So if you look here, we have an application, a Flutter application. And we have 3 buttons on top that allow us to filter information that is entered on the screen. And then we have a text field that allows us to write some text. And we have 2 buttons in here that add items and remove items from a list. So if I, for instance, here write hello and tap the add button, the text field gets cleared and that item then gets added to a list that is right here. I can make the screen bigger so you can see it better. If I then go ahead and add world in here and then tap add and say Redux as well, then we can also say this is a very long sentence to test filters, okay? So, and another one that is very short. So these are the texts that we've entered in this application at the moment. So our store or the state is holding on to this list. Now let's go ahead and press all. What all does really, it just displays all the items that you've entered in the list. If you press the short items, there is a filter in our application state that displays items that are 3 characters or less in length. However, if you press the long items, it displays items that are 10 characters or more in length. So you can also clear the filter by tapping the all button in here. So these are our filters. They're changing the state of the application, and all of this is working using reducers, as you'll soon see. Let's have a look at these buttons. You saw the add button already, so it adds an item to your list. And also we have this remove button. And the way the remove button works is you enter something in here and then you press remove. And that remove will look in the list of items that you've entered, looking for that item. If it finds that item, it will remove all its occurrences from that list. So if I enter hello again in this list, then we have 2 instances of hello entered here. Let's see, I'll bring it here. Then if I type hello in here and press remove, then our application will look for all instances of hello in this list and remove them. As you can see here, all those instances are removed. So I can also type ABC in here and tap remove, and that item gets removed. So there are 5 buttons in here, a text field and a list view. So it is not a very simple application, but it's simple enough to demonstrate the usage of Redux and how it helps you create a cleaner code for Flutter applications. In this chapter, in this example, I'm using Flutter hooks, but I'm only using Flutter hooks to create a text editing controller. I have prepared a video for you right before, like in this actual playlist, in the playlist of Flutter State Management course on YouTube, that I've explained Flutter hooks thoroughly. So it's about 2 hours long video. I talked about Flutter hooks extensively and how we can use it to create Flutter applications a lot easier with more reusability. So I strongly suggest that you have a look at that video first, because the video goes through text editing controllers, scroll controllers. We'll have a look at memoiz, use effect, everything in Flutter hooks. So just so I'm upfront with you, I'm going to use Flutter hooks at least for this first example in this chapter, and I will try to explain it a little bit, but I'm not going to go into too much details because there is already a video explaining that in this current playlist that you're looking at. And if you don't know where that video is, just look at the description of this video at the bottom of the screen. I always link to the entire playlist of this course. So tap on that link, go to the entire course contents, and have a look at the chapter where I talk about Flutter hooks. Okay, now that that is out of the way, let's now go ahead and create our application's source code. So I'm gonna bring terminal up here, and let's go ahead and create our application. So let's say Flutter create, and I'm gonna say Redux example course, and I'd like to enter the organization as well, but you don't have to do this. This is just my company's reverse domain name. And I'm just used to doing this simply because it's always easier to set it up from the beginning than having to do it later. Okay, let's go to this Redux example course, and then I'm going to bring up Visual Studio Code, and let's make this maximize on the screen so you see it better as well. And let's go to our main Dart file. As I've explained this many times before, I like to change the default code when I create a new Flutter application to a simple scaffold application. And for that, I have a code snippet that I called FSA, as in Flutter scaffold application. So I can always remove all this code and type FSA in here. FSA here, Flutter scaffold application. And all this does really, it creates a main function here for me with material app in the main function and run app. And then it will also create the home page in here as a stateless, which as you can see in here. So there's nothing fancy about it. It's just I have a snippet to do that, but you may want to do it by hand. And if you want to do it with the snippet like I did, I have a video on YouTube where you can actually learn how to create custom snippets in Visual Studio Code for your Flutter application. So have a look at that video as well if you're curious about custom snippets. So the first thing that we're going to do in our application is to add Redux as a dependency. Redux is a third-party package freely available on PubDev, and we can bring it into our application, our Flutter application, using the flutter add command. So I'm going to bring a terminal in here. Oops, if I can bring it up somehow, if I can press the right buttons in here. So I'm going to say flutter pub add Redux. Okay, so this is the third-party package that is the base of everything Redux related. Okay. However, since we're developing a Flutter application and we're working with widgets and things that Redux itself doesn't necessarily have to know about, there is another package called Flutter Redux. And Flutter Redux will allow you to integrate Redux and Redux stores into your Flutter application by giving you the ability to build your widgets from a store, from the state of your application. So if you're a Flutter developer and thinking of using Redux, you always have to bring in these two libraries, Redux and Flutter Redux. So let's go ahead and add Flutter Redux as well to our application. So I'm just going to say Flutter pub add Flutter Redux. Okay, just like that. And that's going to bring Flutter Redux into our app. Okay, as I mentioned, I'm going to use Flutter hooks just for this example, and we're going to create a text editing controller with this with Flutter hooks. And if you don't want to use Flutter hooks, to be honest with you, if you're not bothered by learning Flutter hooks, you can also go ahead and change your home page to a stateful widget and create a simple text editing controller. You can do that. It's not a problem. It's just I'm more used to using Flutter hooks, and it gives me a great, or gives us a great level of abstraction, and it gives us the flexibility and possibility to reuse a lot of code. So if you don't want to use Flutter hooks, that's completely fine. Change your home page to a stateful widget and just create a text editing controller. As you'll soon see, you don't have to do it now. Okay, now what we're going to do first is to go ahead and create our filters. So these filters are those three buttons that you saw at top of the screen. So I'll bring it here. You can see it's called all, short items, and long items. So let's go ahead and create that filter in here. I'm just going to say enum item filter, all, long text, and short text. Okay, so here we have that filter. And while all of this is happening, I'm going to do a select device and iPhone 13 Pro and run this application as well, because that operation always takes a while. So I always like to, when I start my Flutter application, I like to select device and run the app while I'm doing my coding. So the application is ready in the simulator or a real device as well while we're doing our work, okay? So now this is the exciting part, because what we need to do in here is to start actually defining our application state. And this is something that may be a little bit strange to work with when you're starting with Redux, because when you're not using Redux, you don't really have to think about your application state until you've maybe put some of your UI components together. But when you're working with Redux, it's very important that you think about your application state from the absolute beginning. Think, okay, what kind of actions is the user going to perform? Or what kind of side effects is this action having on the application state? And as a whole, what is my application state? Like, how do I define these states and how do I express those states? So I feel like Redux helps by us having to define these states from the absolute beginning. It helps in making the application's context and making the application's usage clear to us as developers as well. Because sometimes as developers, especially when you're developing something for your own projects, for instance, a personal project, you just throw yourself into the code without really thinking how the application state is going to work. You just throw yourself in there. I mean, I do it myself. You throw yourself in there, you start creating some widgets, but then you be like, oh, but how is this all going to connect to each other? So I think Redux helps quite a lot in that, and you'll be the judge of that by the end of this chapter. Let's go ahead and then define our application state. So this is going to be an immutable class. So let's just mark it as immutable. And we're going to call it a class state here. Okay, so that's our application state. So this state always needs to hold on to a list of items. So that is the items that our list view is going to display to the user. However, this list, or this iterable as we're going to call it, it could be empty. As you saw in the beginning of the application's execution, that list was completely empty. So we will just hold on to an iterable of string, and it is completely fine if it is empty. You may go ahead and decide that, okay, well, let's make that list optional. Yeah, you could do that if you want to, but I'm not going to make an optional iterable in this part of the chapter at least. But if you want to experiment with it, go ahead. That's completely fine. So let's go ahead and define that. Let's say we have an iterable of string here, and we're going to call it items. Excuse me. Then let's go ahead and say that we need to define our filter. So this filter is going to be an item filter. So let's say item filter, and this is going to be our filter, as you can see in here. Okay. So our state holds on to only two properties. It's very simple. One is the list of items, or an iterable of string here of our items, and then a filter. It's very simple. Just two properties for this state. Error lens, which is this extension Visual Studio Code that I'm using, is telling us that we haven't initialized these variables. So I'm just going to go ahead and do that right now. Get help from Visual Studio Code to define the constructor. And I'm going to say const, then put this here. Then I'm going to say these are required properties like this. Okay. Let's put this into curly brackets in here as well to make these required properties. Great. So as you can see, since our class is immutable, then I'm defining a constant constructor. This is very important because this signals not only to you as a developer, but anyone who wants to, for instance, use your state, that, hey, this state is immutable. We've actually marked it as immutable. So if you remove this const, you can see Dart Analyzer is giving you some diagnostic messages in here saying, hey, you have an immutable class, but your constructor isn't defined as immutable. So, sorry, as constant. So I think it's very important to actually mark your states in Redux as immutable to indicate not only to yourself, but also whoever's consuming this state that when you get the state, nothing inside it is going to change. Is a constant, is an immutable class instance. So don't worry about any side effects changing the state while you're consuming it, okay? All right, so what we need to do now, since this items iterable is actually the entire collection of the items on the screen, we aren't really able to, or we shouldn't go and change that based on your filter. So when the user changes this filter, we shouldn't go and change this items, because remember, there was this all filter on the screen. And as you can see in here, pressing which, that button, when the user presses the all button, we should always reset the state to its to display all its items. And if you go ahead and change this item's iterable in some way or form, then you can never go back to how it was before. So what we're going to develop in here, as you can see at the bottom of the screen, is to create a getter that filters this iterable using this filter right here. Okay, so let's go ahead and develop that right now. So I'm going to say an iterable of string, and it's a getter, and we're going to call it filtered items. Okay, filtered items, if I can spell. So this filtered items, it's going to look at the filter in here. So let's say switch filter, and then I'm going to get help from Visual Studio Code in here and add the missing items for that switch right here. And as you can see, it says item filter all, long texts and short texts. In the case of all, we just return our items. So we're just going to say return items, because those are all our items. In the case of a long text, we are just going to make the decision saying any item that is longer than or equal to in length to 10. So this is just a rule I'm making up, to be honest with you. It's the definition of a long text for me, or for this example, could be anything, but we're just making some numbers up right now. So we're just going to return all the items in our items iterable whose length is more than or equal to 10. So let's go ahead in here and say return items where that item, or let's say element, and then we're going to say element length is more than or equal to 10. And that's it, really. And we're then going to copy this code in here. And I'm going to bring it here to where we're calculating the short items in here. And let's say length is less than or equal to 3. So this is, to be honest with you, all made up numbers, nothing scientific going on in here. I'm just trying to demonstrate that, yeah, long text could be anything that whose length is more than or equal to 10, and short texts are texts whose length are less than or equal to 3. So it's just made up. Don't worry about it. You can change these numbers if you want to. All right, now that we've defined our so what did we actually define? We defined our filtered items that we're going to then consume in our Flutter application in order to display the list of items to the user, okay? So we're never actually going to consume this iterable of items to display to the user. The thing that is going to always be displayed to the user in the list is this filtered items, because this takes into account the current filter on the application state, all right? So this is going to be interesting because we're going to define our first action, but it is very common in Dart, since we don't have yet enumerations with associated values to define your actions that are inside your application derived from an abstract class. So it is good programming practice and a development practice to have an abstract class that encircles all your other actions. So all your actions in your entire application, or your Redux actions, are going to be abstracted away inside, or not maybe abstracted away. They're going to come from and extend an abstract class so that they're all in the same category. So we're going to go ahead and create this abstract class right here. So immutable class action, okay, and then let's create a constant constructor for it as well. So this action is completely empty, is an immutable, and actually we have to call it and make sure it's an abstract class as well, so it doesn't yet have any logic at all. But all the other actions that we will create in this example, they will come from and they will extend this action class. This is just a good way of categorizing all your actions coming from the same class, action in this case. And you've also added the constant constructor to it. So what we're going to do is now to create an action for changing the filter type. As you saw in the application, if I bring it back up here, these are 3 buttons that allow us to change the filter type on our store, or sorry, on our state. If you remember here, we have the item filter in the state. So every time the user taps on any of these buttons, then we're going to dispatch an action to our store, which in turn dispatches that to our reducers. Don't worry about it. I understand it could be a little bit complicated to think about it right now, but just think one thing at a time. Think that we need an action, which is a side effect of the user tapping on any of these three buttons on top, that with itself contains a new filter. That's really it. We just want this button to dispatch that new filter to some place. We don't know how. We just know that this action is only going to be fired by these three buttons, and each of one of those buttons is going to just tell someone that, hey, the item filter changed to all, long texts, or short texts, okay? And here in the UI, we have short items first, and here we have it last, but that doesn't matter really. The ordering doesn't matter. So let's go ahead and create this action in here. So let's call it an immutable class in here. And we're going to say it is called change filter type action. And remember to extend your action abstract class, okay? The only thing that this class has to contain really is the new filter that our application has to perform on that state. So let's go ahead and define that. So I'm just going to say filter, final item filter, and let's call it filter. And also create a constant constructor for this guy. I'm going to get Visual Studio Code to do that for me. Just like that. So you can see this is just an action. It's an immutable class, and the hot reloading I can see is not working because I'm not in the right application. Now it's working. It's an immutable class that contains the filter that needs to be dispatched to our store. Okay, don't worry about it. I mean, just know that it's an action that is going to change the filter to this item filter that is stated here. All right, so that's our action, and it extends the action abstract class. Okay, so what we're going to do then is to create an item action in here. And this item action, if we go back to our simulator here, you know that we have this add and remove right here, right? They both work with a string. So if I type something in here and press the add button, this add button is going to send an action to our store, say, hey, here's a string, add that to the store. And the remove button also respectively is going to take this string and then tell the store to remove that. So these both buttons are working with a string. So it makes sense to create a superclass for them that holds on to a string, and that would be its own action, but we won't do any work with that action itself. It's just a superclass, okay? And then for the add and remove, we will subclass that class that we just talked about, and we will give them appropriate names, add action and remove action, something like that. And both of those will then subclass that superclass that I just talked about. I mean, you don't have to do it that way, to be honest with you. You could go ahead and just create one action for add, one action for remove, and you'd be done. However, it is usually good practice to categorize your actions, because otherwise, by looking at one action that has no superclass, for instance, a developer is consuming your API may be a little bit confused, like, okay, what is this actually doing? But having a superclass that defines the entire action, like add, remove, blah, blah, then you will have more metadata on your subclasses for any programmer to have a look at and understand what your classes are doing. So let's go ahead and add this class in here. So this is just going to be an abstract class. So let's just go ahead and say immutable abstract class item action. And this one also extends action, just like that. All right. In this item action, let's go back to our application so that hot reload starts working again. And the only thing that this class actually contains is the item that it has to work with. Okay, so let's just say final string, and we'll call it item. And don't forget to create a constructor for it as well. So, and this should be a constant constructor as well. Okay. So that's our item action. It doesn't say yet whether it's removing an item or adding an item, and that's going to be the job of our subclasses to do. Okay. So let's go ahead and create now an action for actually adding items to our list. So we're going to call it an immutable class, and it's not an abstract class, it's an actual class with proper implementation, and we're going to call it add item action. And this one isn't going to extend action, it's in fact going to extend item action, because item action in turn includes this item property in here. Okay, so let's say that we're extending item action, oops, in here, and then we need a constructor. So let's say const, and then we put the constructor in here, and we need an item to work with. And this item, I mean, one of the reasons that we have this item action class in here is not to have to redefine this item property in every subclass. Okay, in here we just call this super item. So our class is getting a free property called item by implementing a constant constructor and calling it super, allowing the super to store that item. So to me, this makes a lot more sense than having to redefine this item in every class. All right, now that we've done that, we're going to go ahead and create an action for actually removing items. So let's say an immutable. Oops, maybe not there. Maybe at the bottom of this. So let's say immutable class, remove item action, extends item action. All right, so it's very similar to add item action. And then we're going to create a constructor for this as well. So const remove item action, and it takes an item, and then it just calls a super with that item. So it's almost identical to add item action, to be honest with you, except that it's the name of the class is different. And you'll soon see why we have these classes. It may be a little bit redundant for you to think, oh my God, how many classes? That's okay. We're doing this simply because Dart yet doesn't have enumerations with associated types, something that other languages have, for instance, like Rust and Swift. So we're doing it just for that. We have classes until Dart supports enumerations with associated values. All right. Okay, so what we have right now is like really the bare bone of our like the bare bone implementation of our Redux application. We haven't really come to the juicy parts, which is the actual logic. But what we need really in here, based on our iterable string in here, what we want to do is to, for instance, be able to add an item to that iterable or remove an item from that iterable. And there are functions on that iterable that allow us to do that. However, I prefer to use extensions. I made a post about it recently on Twitter. And if you're not following me on Twitter and LinkedIn, please do, because I do put a lot of content out there as well. I actually put a content related to this, how you can add items to an iterable and remove items from an iterable using extensions in Dart. So I think that's like an elegant way of adding and removing from iterable. So let's go ahead and start implementing these extensions. So let's just go ahead and create one extension. We're going to call it add remove items, and then we're working on T on iterable T. Okay, so by doing this T thing business in here, this allows us to say that, hey, we know that we're extending an iterable of this type. Allow us in the extension definition itself to use T, okay? Because if you did it like this, then you wouldn't be able to refer to T in here because T isn't defined. But by defining it like this, then you can actually use T in here. And T is just any type that your iterable is holding on to. So let's go ahead in here and actually define our plus operator, okay? So the result of this operator is actually going to be an iterable of type T of the same type. And we're going to call it operator plus. So this is our plus operator. Then we take any other value of the same type that the iterable is holding on to. And we'll just call this followed by, and you shouldn't shadow. So I'm just going to remove this from here. And it's expecting us to give it another iterable that needs to be appended to self or this. And we don't have an iterable to be appended. We just have one element to be appended, and that element is this other here. So this is just, this is just a simple way of saying that, hey, we have an iterable plus that with another item of the same type that the iterable is holding on to, and give me a new iterable. That's really it, okay? So that's that function. And similarly, we're going to create an iterable in here that is the minus operator, okay? And what we need to do in here is just to say, use this where. So we're going to filter items out. And then we're going to say filter out element not equal to other. So we're basically saying keep elements in the current iterable as long as they're not the same as other. And that really means that, as you saw earlier, when we press the remove button, it removes all instances of that particular string. So if you go back to our application in here, which was ready, so let's add another string in here that says world. So now we have two instances of world in here. Now, if I type world in here and say remove, both instances are deleted. And that's the work of this where clause in here. It returns an iterable where the elements are not equal to that element that we're giving it. So as long as that element is not equal to world, for instance, they're being kept and returned in the resulting iterable. Okay. And to be honest with you, this is such an important extension. I suggest that you keep it for your applications as well if you're working quite a lot with iterables. And I mean, we should all be working with iterables rather than lists as much as we can. All right. Okay, so what we need now is to start working with reducers. And this is very interesting, to be honest with you, because it's going to be the first time you're writing your reducers, perhaps. And I mean, there are different ways of writing reducers. One is the very simple way, literally just have one big reducer. And remember, reducer just a function, is a pure function with pure input, immutable constant input, and immutable constant output, no side effects. That's what a pure function is. So you can have just one giant reducer that literally processes every action that comes in and then returns the new state. However, what you can also do is to break your reducers down into multiple functions, multiple pure functions. So in here, if you go back to our application, you saw that we have, for instance, the add and the remove buttons in here. You could have one function that handles both these actions, the add action and the remove action. But what you could also do is to say, okay, but I don't want to do that. I don't want to have a massive function because there may be 5, 6, 7 more buttons in here. I just want to have one reducer per action. And you can do that actually with Redux. So I'll show you how to do that. Let's go ahead and just focus on adding items. Okay, so what does adding items actually do? It takes the current iterable, let's say that it's an empty list, there's nothing in the list. It then gives you an action like the add item action, remember here, and then it will return an iterable. So given the current list and this action, give me a new list. As simple as that, a pure function. Let's go and implement it, okay? So before actually we go and implement that, I just wanted to focus on this. It's really up to you how you define your reducers. I prefer to break them down as much as I can, but if you're just testing things out, you can also go ahead and just create one big reducer. But if you're following along with this chapter, I suggest that we break things down from the absolute beginning, okay? So let's go ahead and add this add item reducer. So let's just focus on its functionality. It has to return an iterable of string. So It has to return a new list, for instance. We call it add item reducer. The name is completely up to us, okay? No one's forcing us to do this. What this reducer takes as parameters is actually the previous list. So we're going to call it previous items, okay? Don't worry about who's going to call this function. We're going to figure it out. It just takes the previous iterable of strings and then an action. And that action is I add item action. That's the action that this function handles. So remember that, okay? And we're just going to call it action. Then in this function definition, what we're going to do is literally going to take the previous items plus action item. So I want you to have a second and have a look at this function and see what it is actually doing. If you look closely, it's returning an iterable, taking a previous iterable and the action. Remember, the action comes from item action, which holds on to an item. Okay, that's why we can access action.item in here, because our add item action holds on to the item. And then we're actually using our plus custom operator that we define in this extension and implement in the add remove item, because you know it is our own function when you select it and then right click on it and say go to definition, and it jumps here. So this is our own function working in here, okay? So it's really just creating a new iterable by appending the contents of this action item to the previous iterable. All right, very simple, pure function. Nothing is mutating in here. Nothing is changing in here, just input and output, okay? Let's go ahead and now do the same thing, but we're going to do it for removing items. So I'm copying this code and pasting it in here, all right? And I'm going to call this remove item reducer. And the action is going to be remove item action. Remember that, okay? And in here, we're just going to say here, remove item action, and then action just like that. So we have previous items. And then this time we're using the minus operator to remove that actions item from previous items. Easy peasy. Nothing special happening in here, okay? So how do we put these two together? And that's an important way of, now we have to actually think about how we put it together. There is a function inside Redux, and it is called combine reducers, as I've mentioned at the bottom of the screen. What this function really does is that it takes your types that you provide in here, like these different reducers, and when we plug it in later into our store, the store is able to look at that function and say, okay, I'm going to go through all the functions that you provide to me. Add item reducer. What parameter or what action is it handling? Add item action. Okay, I will provide this add item action to this function whenever that action actually happens. So it is a little bit abstract. I want you to pause this video to think a little bit about it. These functions are defining what they take in as items and also what action they're handling. And using combine reducers, this Redux library is going to allow us to basically dispatch the correct actions to the correct functions, okay, as you'll soon see. So let's go ahead and create our first combined reducer in here. So let's go ahead and start writing that. So the result of this function is going to be a reducer. And if you go to this reducer, let's see if we can actually see the definition of reducer, as you can see in here. Reducer, if I can get its type somehow, let's say iterable string. And I can't get its type right now. Visual Studio Code is having a little bit of difficulty finding its type, but that's okay. And to be honest with you, that could be because we haven't really imported Redux. So let's go ahead and do that. So let's say package, and we're going to import Redux. And while we're at it, let's go and import package Flutter Redux as well. Flutter Redux, just like that. Okay. Now Visual Studio Code may be able to give us some help in finding what reducer is. It still isn't able to find it. That's okay. So let's focus on our work. This collection of reducers, these two guys, one adds items to an iterable, the other one removes items from an iterable. They combine together, return an iterable of string. They both do. Okay, so wrap that result inside something called a reducer, as you'll soon see how we're going to use it. Okay, so let's call this guy items reducer. Okay, and this thing is actually equal to combined reducers, as you can see the functions defined here. Okay. What do we actually do in this guy? Put the same data type of iterable string in front of it, just like that. Okay. Then in here, your responsibility is to dispatch the correct action to the correct reducer. And again, I completely understand this could be a little bit confusing because it's using a lot of generics in here. But think of it as that you're putting together two functions, two pure functions, and you want to dispatch the correct action to the correct reducer. Okay. So now what we need to do in here is to use something that Redux called typed reducer, as you can see in here, typed reducer. Okay. And this is also generic. It's working with IEEE string. And then in here, also, we have to tell it which action this reducer is handling. So we're going to call it add item action. Okay. And in its constructor in here, we're going to pass it the add item reducer, just like that. Okay. So that's that one. And then we're going to go and do the same thing for a type reducer and pass it in here, type reducer of IEEE string, remove item action, and pass the remove item reducer function in here. And we're getting an error because this whole thing needs to be a list. So I'm going to put a list in there and reformat the code to have a look at it together one more time to see what's actually happening. So this function is grouping two reducers together. Nothing special about that. All these generic types in here, you see IEEE string, they're simply telling this reducer what data type it's working on. So let's go through these generic types. IEEE string here, IEEE string here, IEEE string here, and IEEE string here. So don't get worried about that. That's just the type of data this reducer is working with. Okay, so put that out of your head. You don't have to worry about that. Then these type reducers, if you go into their definition, you can see that they're working with the state and an action. So you have to provide the action as a second generic parameter in here. And this reducer particularly is only working with the add item action. The second reducer is working explicitly with the remove item action. That's why we're specifying the actions as a second generic parameter in this type reducer, okay? And then finally, we're working with this constructor in here. If we go back here, I wonder if you can actually see the definition of this constructor. Somehow go to definition. No, we can't. But anyways, here we're actually constructing this type reducer with this reducer function. Okay. I wonder if you can see the code here. Oh, here, this reducer, you see? And the reducer is a function that returns the current state. Remember, IEEE string, and then it takes an action, and we're also taking the action. Remember, add item action, remove item action, and it's just called a reducer. So yeah, it's just a function basically being passed in here. So this guy is taking care of adding items and removing items from our list. We still don't know how to put it to use, but you're soon going to see how we're going to do that. So what we also need is a reducer for our item filter. So when it comes to reducers, I want you to always think of what does it return, or what data type does it work on, and also actually really, yeah, you have to think of the data type that it works on and also the actions that it can handle. If we go back to these simple reducers, we explicitly said that this reducer works with the add item action, nothing else. This guy works with the remove item action and nothing else. However, now that we come to our new reducer, which is the item filter reducer, we're not going to use this combined reducers because this one we've broken it down into the plus and minus. However, with a filter, it's just one filter. There's no adding a filter, removing a filter. It's literally just one filter being applied. The filter could be all, short items, or long items. So how do we do that? How do we go now and work with this new reducer? As you can see at the bottom of the screen, we have to think of the data that this reducer works with. It works with item filter. So let's go and just type item filter. We don't even know how it's going to look like. We just know that it's going to return a new item filter in here. Okay. So let's call it item filter reducer. All right. And then in here, remember, your reducers are going to take a state of your application state, and let's just call it old state. Okay. And then it's going to take an action. So let's go ahead in here and say action is action. Remember, these actions, they're like global actions. Remember, all our actions are coming from this abstract class action. Okay. And then inside your reducers, you're going to have to check what action actually is, as you'll soon see. So in here, then we're going to say if this incoming action is change filter. Actually, we haven't defined our change filter type action, I think, or have we? Let's have a look. Add item, remove item, item action, and action. Yeah, change filter type action. Okay. If action is that, then, so now that you know that this action is of type change filter type action, you have to return, remember, you have to return the item filter. So you say, then return the action filter, meaning that, hey, if you're trying to change the filter to something that this filter actually includes, then I'm going to return that filter. Otherwise, I'm going to return the old states filter. So this old state is, Redux will always give you your old application state and in turn asks you to return a new state. In this case, our reducer takes the old state and it has to, given an action, return a new item filter. Okay. And again, look, I know this is a lot of like abstract stuff that we're talking about. We haven't even put this to use, so it may be a little bit difficult to understand, but we'll get to it. Don't worry. Right after this, we're going to put this whole thing into practice. Okay. So now that we've done this, we've pretty much prepared all our reducers. We've prepared all our actions. It's time to put it to use and go ahead and create our app reducer. So the app reducer always needs to return a new state. Okay. So what it does, let's just call it app state reducer. And then in here, we take two parameters. These two parameters are the old state, okay? And then an action. We just type action like this, and it's going to be a dynamic parameter, okay? So in here, what we're going to do is to actually return a new state. So let's go ahead and say that this guy returns a new state, okay? I'm going to bring it here. And this state, remember, it has two parameters, items. How do we actually produce these items? Do you remember we have a function in here and we called it items reducer? Okay. So this items reducer needs to take, let's pass it in here. Let's say items reducer, like this. And then we're going to call this items reducer with the old state items. And then we're going to pass this action to it. What happened in here really is that this items reducer that we've defined in here is something called a reducer. And if you look at reducer, really, it's just a function that returns a state. You see, it returns a state, takes an old state and a dynamic action. And that's why we're calling it with the old state items, because here we said that this items reducer, it works with an iterable string. That's why its first parameter in here is actually the items, which is an iterable of string. And the second parameter is the action that it works with. And remember, that action is actually being used inside this combined reducers to dispatch the correct action to the correct function. And the actions are defined here. Again, this is a lot of generics. I know if you're not familiar with generics, this is probably good practice for you. So that's for our items. How do we do with the filter? So the filter comes from our item filter reducer, and we pass it the old state and the action. And that's it, really. That's our entire application state. I mean, this is purely magical because just with functions, we've defined our application state. And this is, to me, it's amazing that we can actually do this. Literally just we're putting logic and then combining it all together to create an entire application state. So this is purely magical. All right, now we're getting to the juicy part. Now we're going to put all of this to use and start working with our Flutter application and the UI part to put it all together. Okay, then, now that we've written our app state reducer, let's put it to use. As you saw in the example application that I showed you earlier, we had a text field on the screen, and then we were retrieving the text from this text field, and that uses a text editing controller. I stated in the beginning of this chapter that it's up to you how you're going to create this text editing controller, but I'm going to use Flutter hooks for that. And I've recorded about 2 hours of video about Flutter hooks and how to use them in your applications, in your Flutter applications, for the sake of reusability and as a means of state management. So if you're not familiar with Flutter hooks, there's a video already for you available on my channel in the same playlist of Flutter state management course. So please have a look at that if you're interested in Flutter hooks. Otherwise, if you don't want to manage your text editing controller with Flutter hooks, you can also go ahead and convert your home page into a stateful widget and then have your text editing controller initialize in the init function and then dispose of it in the dispose function. So as I mentioned, we're going to use Flutter hooks. So let's go ahead and change our homepage in here to become a hook widget. So I'm going to change it here and say this is a hook widget. And let's not forget to import package Flutter hooks as well. And I can see that we haven't imported Flutter hooks. So let's go ahead. I'm going to bring up a Safari window here, and let's go to pubdev, and let's search for Flutter hooks. And as you'll see here, in installing, we can just say Flutter pub add Flutter hooks. I'm going to bring up terminal here, and let's say Flutter pub add Flutter hooks, just like that. And this is going to add Flutter hooks for us to our spec. So now we should be able to in here say import Flutter hooks, and just like that. And then we should be able to write. And also we have this problem in here, which is quite interesting actually, because both Flutter hooks and Redux implement and create this class called reducer, because Flutter hooks as well, as I mentioned in that video I've recorded about Flutter hooks, does have the possibility for you to also use reducers and Redux in Flutter hooks. So they both introduce this reducer. Then now all of a sudden we have this problem that Visual Studio Code, or Flutter in this case, doesn't really know which reducer to use in here. Is it the reducer from the Flutter hooks package, or is this the reducer from the Redux package? So what you should do in this case, you should, but I mean, what I'd like to do at least is to here and say as hooks. And this way I need to prefix all classes that come from Flutter hooks with hooks. So then we go ahead in here. Let's go back to our hook widget. Then we should say hooks.hook widget. So any class or any identifier inside Flutter hooks package will then need to be prefixed with hooks dot for Visual Studio Code or for Flutter to understand where it's actually coming from. That's one way to separate these clashing class or identifier names. Okay, now that we're done with that, let's go to the next state. And that is, for me at least, the most fun part, because here we're going to create the store. Remember, the store is a virtual object, or rather it's an object that holds on to your reducers, and it holds on to your application state. Plus, it will also require an initial state. And after you create the store, your communication with your Redux application or with your Redux state is always going to be through this store. So you have your reducers, you have your actions, you have your state. To put them together, to connect them together, you need the store. And that's what we're going to go and create in here. So let's go to our hook widgets in here and then say final store is store. I just created like this, okay? And there are a few parameters that we have to provide to the store. So the first thing, if you go to the store's creation in here, you can see it actually requires the reducer. So it says, okay, hey, what is your reducer? And if you have a look at the reducer, as you can see, it is actually a reducer of state. So we do have our reducer here. Do you remember? Let's go ahead. Actually, here, app state reducer. So let's go in here and say we have an app state reducer in here. App state reducer, just like that. Okay. And now we're getting another problem in here, and it says, okay, now that you have your reducer in here, what is the initial state? Because the reducers take an action and produce a new state. But when the application runs, when the build function is called for the first time, what should be the current state? And that's what we need to provide in here. So let's go ahead and say initial state. And in here, let's create a new, completely new state in here, okay? And our state class in here requires two parameters, the items and the filter. So let's go for the items in here. Let's say items are empty, and the filter is item filter all, just like that. So when we begin the application, when the build function is called first time, then we create a store with a state where the item filter is all and there are no items displayed on the screen. Okay, after doing that, after creating the store, we also need our text editing controller. So let's go ahead and use Flutter hooks for that. So I'm just going to say text controller is hooks. Use text editing control. And that's one of the reasons I use Flutter hooks, and is that it makes the creation reusability, it takes them to a whole new levels. Like I don't have to manage the life cycle of this text editing controller at all anymore using Flutter hooks. The hook widget is going to take care of that for us. Okay, so when we have our store now, how do we integrate it into our Flutter application? And that's one of the reasons that we didn't just use the Redux package, we also used the Flutter Redux package. And this is the same thing like if you're using Block, for instance. Block itself, the core of the library is just one package. So that package itself is the core of Block. And then you have Flutter Block, which is a separate package that allows you then to talk with Flutter, that allows you to glue together your block with your Flutter application. And the same is true with Redux. So you have Redux package, which is the core of Redux, and then you have Flutter Redux, which brings Redux capabilities to Flutter. And one of the things that is important inside this package that we imported, which is Flutter Redux, is a class called Store Provider. And if you're familiar with providers, I also have a chapter ready for you to watch about providers actually in this Flutter state management course playlist on YouTube. You can go ahead and watch that. But then you should be familiar already with providers. So this store provider will hook itself into a store and then provide you with updates and allows you to create a new widget whenever changes occur in the store and the state of the store changes. So we're going to go ahead and use store provider in our application. So let's go ahead in our scaffolding here and change and set the body of our scaffolding here to a store provider. And then you can see that there is a parameter here called store that we have to provide in here, and we already have the store. So let's just provide that. And then we're going to go ahead and for the child of this, we're going to, as you can see at the bottom of the screen, we're going to create a column because we're going to place all our components in this vertical list, which is inside a column. So let's go ahead and say the child is a column in here, okay? And its children for now are empty, just like that, okay? And we're missing a column somewhere. Okay. Great stuff. What we need to do is to go ahead now and add 3 buttons to the first child of this column. As you saw in the application, let's see if we can actually bring it up in here. So in here, our application looks like this, or it should look like this when we're done with it. This is the column, which is the entire screen. And let me make this bigger as well. And the first component inside this column in here, it should be a row for us that we're going to place 3 text buttons in there. Okay, so an all button, short items button, and long items button. So let's go ahead and create 3 text buttons in here. So the first child of the column is going to be row with its own children. Okay. Um, Forget the const parameter because our text buttons aren't going to be const. And then I'm going to say text button in here on pressed. And then let's say the child is going to be a const text all. Okay. So that's the first text button. Then I'm going to copy this text button. Then I'm going to paste it twice. Then the first one is going to be short items, I believe. And then the third one is going to be long items. Okay, so now that we're done with that, we need to go ahead and actually, when we do, like when the user presses these buttons, let's do a hot restart as well. Let's see if we can go back to our application. Let's do a hot restart in here. Okay, so now when the user presses these buttons, we actually have to dispatch a message or dispatch an action to our store. And this is the exciting part because up until this point, we've only been defining these actions. We've been defining the store and the reducers. We haven't really been interacting at all with the store. The only interaction up to this point, as I can see right now, that we're doing with the store is to hook it with the store provider class so that we get updated, or our column, for instance, this child gets updated on any changes to the store. So that's the only interaction. So let's go ahead and do our first interaction in here in this text button, in this first one. Okay, so when you press this all button, what we want to do is to send an action, and that action, let's go ahead and see if we can find it. It is this one, change filter type action. Okay, and it is an extends action, but in itself has this item filter. So let's go ahead and copy this and go back to our first button in here and say store.dispatch. So this is the function that you use on your stores in Redux to actually send an action to it. And if you look at its implementation, it's a dynamic action. So it could be anything. And that's one of the reasons. I mean, the reason that this dispatch dynamic the dispatch function marks this action as dynamic is the same reason that your reducers ideally should actually accept an action that is dynamic or is not type at all. And that's the reason that you can see in here, we haven't really typed our action. So it is dynamic, and you will actually get into trouble if you try to say action is literally an action, because it just won't work. As you can see, this one expects an action that is dynamic in here. So when you have your app state reducer, make sure that your action parameter is dynamic or it's just not type, which by default forces Flutter to make it a dynamic action. Okay. So here we now need to we need to dispatch something to the store, and that something is going to indeed be this change filter action type. And the filter type in here for us then, item filter and all. So that's literally what we're going to dispatch to the store by pressing this button. We're changing the filter type to this item filter all. Now that we have this code, let's go ahead and paste it in here, short items. So I'm just going to say short texts. And for long items, let's say long texts. Okay, so our buttons are ready now. There's not much more to it, to be honest with you. It's just these 3 buttons that dispatch a simple action to the store. Okay, now that we have these 3 buttons, let's go ahead and put a comma in here. So these are placed inside a row. As you can see, this is the end of the row. Right after this, let's go ahead and add a text field. Okay, so a text field. And for our text field, we shouldn't forget to add the controller. And this is going to be our text controller. So I'm going to hot restart the application. And now I can see that we have a text field right here. Okay, that's fantastic. In this row, in this column, right after the text field, we need to go ahead and add another row that includes this add and remove buttons. So let's go ahead right after this text field, create another row. And in here, let's just say children. Okay, and I'm just going to go ahead and actually copy these 2 text buttons from here. with their actions and everything, and place them in this row and just change their text. So if you go back to the application, it should be add and remove, add, and then we say remove, okay? And on this unpressed, first we need to get the text editing controller's text. So let's say final text is text controller text, because we actually, when you're adding an item to your store, you need to get that item first. You need to actually grab the text that the user has entered in this text editing controller or in this text field, and then send that item to the store. If you remember from earlier, we had these actions defined: add item action and remove item action. They both require a string item in their constructors. So we need to now go ahead and construct that now. So now that we have that, we're going to dispatch and add item in here, add item action, and then pass the text right here. Okay. And this one can't be a constant now. All right. Now that we've done that, let's go back to our application so that hot reload works. And remember, it is always a good idea after a user does something with a text field, for instance, is done with the text field and is trying to add that text field's text to the store, it's always a good idea to clear it. At least I find it to be a good idea. Like if you go back to the working example and I say hello in here, by pressing add, you see the text disappears. This kind of indicates that, hey, I understand that you're done with your changes in this text field. I'm going to clear it for you. Otherwise, every time you enter something in the text field and press the add button, the user has to go and delete that text in order to be able to add a new item. It's just annoying, in my opinion, at least. So it's a good idea usually to clear that text field. And to do that, we're going to say text controller dot clear. Okay. Now that we have this, let's go ahead and copy that and bring it to this remove button as well. So delete the contents of the onPress function in your remove function in your remove button, and instead in here, and then paste the one that we had from add buttons onPress event. And instead of add item, we're just going to say remove item. As simple as that. So one adds, the other one removes. Okay. Let's just save our changes. Go back to our application so hot reload works. Great stuff. Now we need to display our list view. So this is very exciting, to be honest with you. Now we're going to add our list view. So I can see this is the end of the row. So what we need to do in here is go ahead and try to display our list view. And one thing that we need to understand here is that this list view that we're going to create, it has no interest in any other data that is in the store. If you go back to our store and have a look at it, and this store has a state, and here, and if we go to our state, you can see this state has items, filters, and it has also filtered items. Our list view has no interest in items, and it has absolutely no interest in the filter itself, because it's our reducers that are actually changing basically the state of this state class or the state of our application. The list view, the only thing it's interested in is this filtered items. So for that, there is for you to be able to actually cherry pick what you're interested in inside an application state with Redux, there is a component called store connector. Store connector, it allows you, it's kind of like a widget. It is a widget that you can place on your Flutter application. And what it does, it reads the contents of a store, but it is able to cherry pick what it is interested in. And once the store changes, every time the store changes, this conversion then takes place. It says, okay, here's the entire store changes. Go to the store connector. The store connector then cherry picks what it's interested in. And then when the build function of your store connector gets called, only your cherry picked contents will be passed to the build function. I'll show you how it actually works. So let's go after the creation of this last row with our buttons. Let's go ahead and say that we're creating a store connector. And this store connector, we're going to say that it works with our application state. But what it really is interested in inside this application state is an iterable of string. And remember, this iterable of string is going to be then our filtered items. Okay, so first you define the entire state, then you define what you're interested in from that state. Okay, so let's go ahead in here and then have a look at the two important parameters that we have to provide to the store connector for it to actually work. One is this converter. Okay, so we're going to go ahead and actually, I'm going to bring up this title at the bottom of the screen so you know what we're working on. So this converter, if you have a look at its definition, it's a store converter. And what it does, it is that you can see it returns a view model and it gives you the store. So let's say in here, store, then you need to return the so-called view model. And it could just be anything, really. What do you return? You take the store and you return something from it. And we're literally saying in here that we're returning an iterable of string. So that's our view model. Okay, so let's go ahead in here and say we're interested in the store states and it's filtered items, That's what we're interested in. Okay. And then what we need to do is to go ahead and do this builder in here. And the builder actually takes it gives you a context and then it gives you your view model as well. Okay. So in here, your job really is to return now, let's say return container. Now you can see the errors are going to go away. So given this items, as you can see, this is going to be an iterable of string because this is your filtered items. Given this, you need to return a widget to be rendered. And so now you've basically converted or connected your application state and converted that state's changes to your filtered items. And then you get those items to display here. It can't be easier than this. It's for me, it's like a dream because it's just so clean. But that's my personal opinion. So let's go ahead in here and then return our list view. But remember, list view, it kind of needs to know its size, like how big does it have space to render its contents. So if you just place a list view in the middle of nowhere, it's not going to go so well. You're going to get errors telling you that, yeah, I don't know my size. So a good practice is to put it inside and expand it. So we're going to go ahead and here, say we return and expand it. Its child is going to be a list view builder. Okay, and in here we have a count, item count, and the item count is going to be equal to items length. Okay, remember this is our view model as Redux calls it. And then we have the item builder. An item builder in here, I don't think we're going to get help for that. It's going to have the context and then an index. So given this context and the index, we need to first find the item. So let's just say final item is items element at index. Just like that. So we got the item. So this is the text that we actually have to render. So remember again, we are extracting an iterable of string from our state already. So that comes in here. So you're literally working with an array or a list or an iterable of strings, and then we're creating a list view for that. So it's very simple at this point. Then let's go ahead and say we return a list tile whose titles are text of item. There's so much help in Visual Studio popping up everywhere. It's just so difficult to see the actual code that we're writing. So I'm going to do a hot restart. And let's go ahead now and see how our application actually works. So this is our app now. Okay, I mean, we know that it is our app because if we say put an A here, it appears here. I'm just making sure that it is not the other app that I was just showing you in the beginning of the demo. So, or in the beginning of this chapter, because I'd already prepared another app here, you see. So this is our app for sure. Let's go ahead in here and just say hello and then press the add button. And you can see that the item appears here. And I'm going to say world add. If we say all the items appear here, let's add some, this is a very long text. And right, press the add button and then say ABC add. Now, if you say all the items are displayed. If you say short items, only those items that are 3 characters or less are going to be displayed on the screen, and long items, only the items whose length are 10 characters or more are going to be displayed on the screen. Now, if you say all again and then test the remove functionality, so if we say hello in here, then press the remove. And if you say world, now this is the interesting part, because if you say world, nothing changes simply because our removal, if you see here, where we added this minus operator, is only, it's literally just comparing the items. So in the case of a string, comparison is going to be case sensitive. So you may want to go ahead and expand upon this example and make the comparison case insensitive, meaning that, or not case sensitive, meaning that even if you enter hello world in here with lowercase w and press the remove button, then any casing of the word world will be then removed from the list. Okay, so I'm not going to do that, but I think maybe a good practice for you would be to actually expand upon this example. All right, we're done with this example. I spent quite a lot of time, and you've spent quite a lot of time now going through the basics. I tend to actually do this to explain, or sometimes even over-explain the basics, because I think it's so important to lay a good foundation for our work. And in the coming examples, we have 2 more examples to have a look at in this chapter. I'm not going to spend as much time explaining the basic concepts, because now you know you have the store connector, you have the reducers in your head, you have the store, you have the store provider. All of these I've already explained, and you've gone through them, so I'm not going to explain them more. Great stuff. Now that we're done with this example, let's go ahead and commit our code so that we don't mess it up. In here, let's just say git init and create a repository in here. And git status, let's just say git add all, and let's say git commits step 1. And then I'm going to say git tag step 1 as well in here. Great. So if you look at our tags, we have step 1, and then we have the log, which is step 1 as well. Now that we've committed our code and we're ready to start having a look at the next example in this chapter. And for this example, we're going to be doing some asynchronous work, because in the previous example that we had a look at, all the work that we did were synchronous, in that we had the user entering some text on the UI, and then we were adding it to the list and removing. Everything was synchronous in that way, that any message being sent to our store was synchronous, the processing was synchronous, there was nothing that was happening asynchronously. And I think it's so important to have a look at asynchronous examples with Redux as well, so you can see the great abstraction level that you will receive from Redux when you're creating asynchronous middleware, as it's called in Redux, as you'll soon see. So we've seen how the basics work, and it's time to have a look at asynchronous examples. So let me show you what we're going to develop in this example. It is very simple. It's just it's a simple Flutter application with a scaffold and just one button and a list view. You can't see the list view yet because we haven't loaded the contents into the list view. We have a simple button on the user interface. User can tap on this button, and then then the contents will be displayed here. But the important thing to notice here is that this content is being actually loaded dynamically, asynchronously, and the JSON parsing is also happening asynchronously inside a function. So what we're going to do, we don't have to have a custom backend or anything. There's no Firebase integration in here, but we're going to use an extension in Visual Studio Code. And we're going to use this extension called Live Server in Visual Studio Code. And it simply allows you to host your entire current project as web contents with a local web server. Okay. So the key to asynchronous Redux functionality is using middleware. If you're like a Django developer, like I am as well, you already know what a middleware is, so there's no reason to actually explain it. Middlewares are used in Redux as well as many other libraries or packages, not only in Flutter but also in, for instance, the web development world or like the backend development world, to create a piece of software, as its name indicates, that sits in the middle of 2 other things. So usually requests come in just flying by into a middleware, and the middleware can then intercept those requests and do something about them. And that's exactly the same thing that is going to happen in our Flutter application with Redux now, is that, as you'll soon see, we will pass a an action that says, for instance, load people, and our normal app state reducer is not going to handle that action as much. Only that action is going to fly by from the application's reducer into something that we call a middleware, which is simply just going to be a pure function as well. And that middleware is then going to intercept that load action and then load the JSON, or call the API that's required to do, parse the JSON, and then pass that state back to our application state. Okay. So one thing also to note is that in our middleware, when we're working with Redux, we're not actually going to do async await calls. So our middleware is not going to be an async function, and it is not going to do any awaiting. So it is a little bit of a strange thing to think about, since it's doing asynchronous work. But what it's really going to do is to kick off a future, and in this future is just going to use simple future functionality such as then and catch error in order to communicate with our store or with our application state, as you'll soon see. Okay, now that we've talked about the basics of what we're going to develop, now let's go ahead and actually do that. So this is our application state at the moment, if I can find my keys behind the keyboard. So here's our application state now. Let's go ahead and clear everything in here. Let's keep our imports for now. And then I'm going to delete everything and then put a simple scaffold application in here, remove this material because it's a duplicate, and save this file and do a hot restart. So your application should basically look like this, with a simple main function with material app in it and a home page. Okay. So in this particular example, we're not going to use Flutter hooks, and we're not going to use Flutter hooks, to be honest with you, for the rest of the examples either. So you could just go ahead and remove this import completely in here. And if we're being a good citizen of the Flutter land, we would go ahead and say Flutter pod remove Flutter hooks as well. Because yeah, we don't really need Flutter hooks for this example. And we've also committed already our previous example, so you can always go back to it if you want to. Great stuff. That's for the cleanup, to be honest with you. So let's now go ahead and add our API, and that API is just going to be a simple JSON file in the current working directory. Okay, so let's go ahead. I'm going to collapse these, and I'm going to go ahead and say new file in here, and let's say API, as you can see at the bottom of the screen, people.json. Okay. So here we have our people JSON, and I'm going to go and see if I can actually grab the contents. And this people JSON is going to be an array of 2 objects. Every object has a name key and an age key. The name is a string, has a string value, and the age has an integer value. Okay, so that's people JSON right there. Okay, now that we've done that, how do we actually get that as a URL that we can then use with HTTP client inside our application? And the way to do that in Visual Studio Code is to do Command-Shift-P on a Macintosh, or Control-Shift-P with Linux and Windows, and then say live server, and then just say open with live server. Okay. And here it is. Now we can see the port is 5501. And to be honest with you, the reason behind that, I think the port is actually usually another one is 5500 or something, but I have live server already running in this demo application. That's why it opened it with this port, but that's okay. Let's just make a mental note of that. Okay. And if you go to this API folder, we see our people JSON. So this is the URL that we have to call in order to grab the contents of this JSON. Okay. So now that we have that, let's go ahead and define the URL. As you can see at the bottom of the screen, I've written the port 5500 because that's usually the port that live server assigns to your server. But I have 5500 already assigned to another application, which that port is already consumed. So for me, it will be 5501. But if you don't have live server running in your application, go ahead anywhere else in your system. I mean, go ahead and use what I've mentioned mentioned at the bottom of the screen, which is 5500. Okay, so I'm gonna go ahead and define that port in, define a URL in here. Let me see if I can be super lazy in here and like copy and paste that URL somehow. So that's that one, okay? And I'm gonna go ahead, and for me, I'm gonna change it to 5501, but for you, it's probably just gonna be 5500. Okay, now that we've done that, we need to go ahead and define our person class. Okay, so we need to have the person class that has the name and the age properties. We're also going to add some functionality to this person class that allows it to be parsed from JSON, and also we're going to override the toString function on that person class. So let's go ahead and actually do that right now. So let's say immutable class person in here, final string name, okay, and final int age, I believe we call it. So let's go ahead and add the constructor in here, and this constructor is going to be a constant constructor, and add these two parameters in here. I'm going to go ahead and make these required, and put the curly bracket in here to make these required named parameters for the constructor. Great stuff. Now that we have that, let's go ahead and create a constructor for this class that allows it to be then initialized or constructed from a JSON object. So if we go back to this thing that we had in here, this is a JSON object, as you can see, is a map with keys of string and values of dynamic, because one value is a string and the other value is an integer, meaning that the entire map will be a map of string keys and dynamic values. So given a map of string dynamic, we need to create an instance of this person class. So let's go ahead and say person from JSON, and then we get a map of string and dynamic in here. And then let's call it JSON. Then we say in here, our name is equal to JSON name as string, and then age is JSON age as string, as int. Great stuff. Now that person from JSON is complete. Then what we need to do in here is to go ahead and say we are overriding the toString function in here. Okay, so let's say in here the string is going to say person name, and then age years old, just like that. All right, so that was a simple functionality of our toString function on the person class. Great stuff. Now that we've done that, we should actually go ahead and create a function that is going to fetch the contents of this URL. So given this URL in here, API URL, we need to be able to fetch instances and iterable of person from that URL. Okay, let's go ahead and implement that right now. So let's say that our function returns a future of iterable person in here. Okay, and we're going to call it get persons, as you can see at the bottom of the screen. And I usually go ahead and just use HTTP client. A lot of people go ahead and use the async like package. I really don't think you need any other clients other than HTTP client for doing like basic work, because almost every other package that's doing like API calls is using HTTP client at its heart. So it's a good idea usually to use HTTP client unless it gets too complicated for you to use. So let's say we have HTTP client in here, and then we're going to say get URL, and also we have to import IO, I believe, Dart.io. So Dart.io is now imported, and you should be able to use HTTP client. Okay, so let's say we want to use get URL, and in here we're going to say URI parse our API URL in here. Okay, and after doing that, what we need to also do is to go ahead and close our request. So we're going to say then, and this is our request. Let's say request close. After doing that, we get the response. So let's say response in here. And we're going to transform this response. So let's say resp.transform it. Okay. And we're going to use the UTF-8 decoder. So decoder. But we have to import, I believe, Dart convert for UTF-8 to actually work. And then we're going to join that whole thing. So it gives us a string. This join function will give us a future string. Okay, so this is decoding the entire data with UTF-8 and then putting the entire data stream back together with join function, which gives us a string. So in the next then, in here, we actually have a string to work with. And then we have to parse this string as JSON. So let's just say JSON dot decode the string as a list of dynamic. Now that we have the list of dynamic, we have to map every item, every element in that list to an instance of person. So we do that in the next then. So we say list, and then we say list dot map, and these are the elements of the list. Then we say person dot from JSON of that element. And that's it really. Now we have our JSON downloading or fetching, and then we have our JSON parsing. And this should be very familiar for those of you who are familiar with JavaScript, for instance, or even TypeScript, I would say, how you can chain these then functions with each other. So pause this video if you want to have a look at this code. So it is quite simple. It is a pattern that you'll do more over and over again if you're doing JSON downloading or JSON fetching and parsing. So there's nothing special about this function, to be honest with you. It's just doing a simple task, but it may look a little bit intimidating to begin with. Okay. Now that we have that, we need to define an action for loading person instances. You saw that the button was the key to this application. So when we went here into this class, into this user interface, and we press the load persons, that button sends an action to our store or to the application state saying that, hey, you now need to download the contents of the JSON and then parse it. So we need to define an action for that. So I'm just going to go ahead in here. Let's go and define an immutable class for all our actions, as we did in the previous example, an abstract class action, okay? And then let's say const action first. Then let's go ahead and add as you can see at the bottom screen, a class for actually loading the contents of that JSON file. So I'm going to say immutable class and load people action extends action in here, okay? And this action really has no payload. It has no information to be passed to its receiver. It's a simple message of saying, hey, go and load the contents now. That's it, okay? So it has a constant constructor with no properties, no arguments to the constructor, nothing. It's just a signal to the store saying, hey, go ahead and do something. Okay, and when we're doing fetching, there could be errors. There could be errors along the way. For instance, the JSON is not parsable, or that we couldn't actually fetch the JSON. So we have to now define two separate signals to the store to say, hey, either the downloading and parsing went successfully or it failed. And these signals that you need to send to your store, remember, all these signals need to be actions. Okay, so even though these actions aren't going to be actions that the user initiates, because the load people action is a user initiated action. When the user presses that button, this action is going to be sent to the store, and then the store is just going to go through its reducers and then produce the content that the user expects. However, we need two actions, one for successful downloading and parsing of the JSON and the other one for a failure in doing so. And these actions are not user initiated. They're going to be initiated from our middleware, as you'll soon see. So let's go ahead and first define the success action. In the case that our API went through successfully and we could fetch the persons, as you see in here, we actually retrieve an iterable of person. So this action's payload needs to include this iterable of person with itself in the case of success. So let's go ahead and say an immutable class successfully fetched people action, and this extends action, okay? And let's just say final iterable of person, and this is persons, okay? So this action should always include with itself the actual iterable of person classes that were fetched successfully. Let's go ahead and create the constructor for this, and I'm going to say const, and let's just say required parameter this persons. Great stuff. That one is done. Then we need to go ahead and define the action for whenever things go wrong, whenever the fetching or the JSON parsing goes wrong. So let's say immutable class failed to fetch people action, extends action. And in here, we're going to have a final object error. So in case any error happens, we actually want to catch that error, okay? So a constant constructor and a required parameter in here. Great stuff. Now we have both these actions. And remember, again, these actions are going to be called, they're going to be invoked or dispatched by our middleware, as you'll soon see how. Okay, so what we need now is actually go and define our application state. And this is very important because in this state, we're going to actually have an empty state as well. So remember in the previous example, when we created our store, the store said, okay, what is the initial state? And then we hard coded that initial state in the build function. But you can also build into your state class like an empty or initial state that your consumers can then use, as you'll soon see how. So let's go ahead in here and define our application state. So I'm going to say immutable class state, okay? And this state, in this case, we're also going to add a loading state to our application. So let's go ahead let's go back to this example. And when we first run this application, let me see if I can hot restart it. And then if I press this load persons button for a very, very short period of time, you will see this button turn into some sort of a loading state. If I press it, it was just so fast you couldn't see it. But what happens really is that when you press this button, a signal will be sent to the store telling it, hey, it's time to download the contents of this JSON and parse it and give that content back to me. While that content is being downloaded and parsed, then the state will go into this loading state. And we're going to add a Boolean variable in this state that indicates whether it's loading or not. And while the Boolean value is true, then we're going to change this button. Instead of displaying a text button, we're actually going to display a circular loading indicator. And this would make a lot more sense if you were actually calling an API on a remote server that could take some time, because then you can actually see the loading indicator. But since we're hosting this JSON file on our local computer, this transaction is going to go through so fast that you're not going to see the loading indicator at all. But still makes sense to add it to our state just to demonstrate the functionality. So now that you have that in your head, let's go ahead and say final bool is loading. So that's one of the states of our application state. Okay, then let's go ahead and say we have an iterable of string in here, but it's optional, and we're going to call it fetched persons because, yeah, initially it's going to be null because we have no fetched persons, and an optional object of error as well. Okay, let's go ahead and add a constructor to our state. I'm going to say const and required, sorry, in here, curly bracket, and let's go and make all of these required. Okay, so that's our const state. Then let's go ahead and define an empty state as well, or like the initial state. So I'm going to say const state empty, just like that. And in here is loading is going to be false. A fetched persons is going to be null, and error is also going to be null. So that's our initial or empty state. I mean, you could call it initial if you want to. That's fine as well. I'm just calling it empty. It doesn't need to be called empty. That's what I'm trying to say. Great stuff. Now that we've done that, we should go ahead and actually write our application reducer. In this example, I'm not going to use these combined reducers at all. I'm going to show you a vanilla reducer because, to be honest with you, we can't really go and use a combined reducer in this example because we don't have two or more reducers that are doing something similar. It's just one action coming in, and we have to basically react to that action. Okay, let's go ahead in here. So we say we want to create a reducer. Remember, a reducer always has to return the application state, and we're going to call it reducer in this case. It gets the old state and a dynamic action. Okay, so then we're going to say if action is load people action. So what do we do when this action comes in? Remember, in this load people action with it's the time when we actually get that action, it is time then to go and fetch something. It is time then to go and parse something. However, this function is not an asynchronous function. It needs to immediately return a state. Remember from the beginning of this chapter, this needs to be a pure function. It is a function that synchronously takes an old state, takes an action, and synchronously has to return a new state. So now that we can't parse, now that we can't download or fetch or parse anything in here, what should we do? Okay, we completely need to ignore and forget anything asynchronous in here. So that's the job of the middleware. We haven't come there yet, okay? But just think about the synchronous aspect of this load people. When you say load people, then the state should go into the loading state, right? We have a property here for it, is loading, right? So the only thing we can do really is just to set that is loading property to true and return the new state. So let's just go ahead and do that. So we say return const state, okay? Errors is null. Then we say fetched persons is null and is loading is true. So that's really the state that we're returning in here. We say load people action comes in, the state is loading. That's all the reducer can do. It can't do anything asynchronous. So that's the job of the middleware, which we haven't gotten to yet. Okay, then we say, well, we have two more actions. If this successfully fetched people action comes in, then we have to take these person triple and set it on our state. So then we say else if the state is this one, then we say return a state. Error is null because, yeah, we just said that it successfully fetched. Then we say fetched persons is state. Let's see. Else if, sorry, action. Is action persons. So we take the persons that were fetched and placed inside this object, and we place them inside the state. And if we actually have successfully fetched the people, then is loading should be false. So that's it really. Let's see. An iterable person can't be assigned to the parameter type iterable string. How come? Why not? Fetched persons. That's an iterable of person, or did we say iterable string? Oh, that's incorrect. I apologize for that. This should be an iterable of person, fetched persons. Okay, so that's that. Now that we've handled successfully fetched people, we also have to handle this error case. Remember the error action, failed to fetch people. So let's go ahead and handle that right now. So we say else if action is this, then we return a state. The error is the action error. Remember, this action actually includes the error that has happened. Then we say fetched persons, then we actually take the old state's fetched persons. So we say whatever the old state had as its fetched persons, set that in there as well. Okay, this allows us basically to hold on to the previously fetched persons in the case of an error, in case we just want to display the previously fetched persons as well in our list, even though an error just has happened. So, and then is loading should be false because, yeah, we've just failed actually fetching or parsing the JSON, so we're not loading anymore. We still have an error here, and that says, okay, hey, you're handling 3 if statements in here, but what if the action is none of these? What should I do? And in this case, we say, okay, if none of these if statements actually are entered and we can't handle things in these if statements, we should just return the old state. So it means we couldn't handle any of those actions, okay? Great stuff. Now, this is the exciting part. We're going to go ahead and write our first middleware. So this middleware, the function of middleware has 3 parameters. It's very important to actually hold on to these parameters. The first, or sorry, not hold on to remember what these parameters are. The first parameter is this entire store. The store, I don't mean the state, it's the entire store. You will get it as the first parameter. The next parameter is a dynamic action, just like in your reducer, like here, a dynamic action. And then a new parameter, a third parameter, is called a dispatcher, or next, as we call it, and its type is actually called a next dispatcher. And we could go in here and say final next dispatcher. You can see is a type that if I say blind here, let's go into next dispatcher. You can see it's inside Redux library itself, not even Flutter Redux. And you can see a next dispatcher is a dynamic function that takes anything as a parameter. So it is very open, basically. Let me just explain how that actually works. How middlewares work, not only in Redux, but also, for instance, in Django, if you're a web developer, is that you have always an array or a list or an iterable of middleware. You can have multiple middlewares in your system. You have your reducers that synchronously turn actions into new states. That's great. But what if you're doing something asynchronous, that you have middleware? In these middleware list, you can have multiple of these middleware, and Redux will go through these middleware one by one, first in, first out kind of order. That it goes through your first middleware, says, okay, here's an action that just was performed. What do you want to do? Then you say, okay, I'm going to do some asynchronous work. But then you have multiple other middleware after you. It is every middleware's responsibility to pass this action forward to other middleware to also handle. So this next dispatcher, really, it will give you the next middleware in the array of middlewares, if any, and your responsibility as a middleware creator is to call that next dispatcher to say, hey, I'm done with this action. I did what I had to do. Now it's your turn. If you're there, if there's any more middleware than I am, then it's your turn to handle it as well if you want to. So let's go ahead and add our first middleware in here. Our middlewares are going to be void functions in here, and we're going to call it load people middleware. Okay, so this is our function. If you remember, I told you that the first parameter is the store. So let's say that it's the store of our state, and we call it store. The second parameter is our action dynamic. So we're not going to type its data type. And the third parameter and the last parameter is the next dispatcher, and we're going to just call it next. Okay, so now we have our middleware. It's our turn to actually handle something in here. Okay. The only thing that our middleware is going to handle is that load people action. So we're going to say if action is load people action, then we're going to do something in here. So the first thing we're going to do is to say get persons, and that gives us an iterable of person. This, remember, is an asynchronous function, but we're not going to wait on it. We're then going to use the then function in here. So we're going to say persons. Okay. So if we get persons in here, we're just going to say store, dispatch, and then we're going to dispatch an action. We're going to say successfully fetched people, and the persons are person, just like that. And then we're going to use catch error, and this is going to be our error in here. Then we're going to say store dispatch failed to fetch people, and the error is this error. So you can see how we're not doing any awaiting here. We're literally just saying get persons, then store dispatch catch. So there's no await, there's no async function in here. Okay. By no async function, I mean that this function isn't marked as async. That's what I mean. Okay. So that's the basic of the middleware, but don't forget that we have to also call this next dispatcher in case there are more middleware waiting to handle this particular action. So let's just say next, and then in here, we just pass the action to it. Okay. So that's your responsibility. Don't forget to do that. It is very important. Otherwise, I mean, in this application, it doesn't make any difference because we're only going to have one middleware. But in applications where you have multiple middleware, every middleware has to make this next call and pass the action forward. Otherwise, only the first middleware is going to get this message. And then any middleware after that is not going to know anything about that action. All right, now that we have that, let's go ahead and define our store here in the build function. So let's say final store is a store, okay? And first we're gonna add our reducer in here because our reducer function, remember, is here. We just called it reducer. So we pass that as the first parameter. And the initial state is gonna be a const of our state.empty. And then here we're gonna use a new parameter called middlewares, or middleware, and this is a list of middleware, okay? And in here, what we're gonna do is to go ahead and say load people, what do we call it? Load people middleware, or what do we call it? load people middleware. I'm just going to copy that name and put it there. So that's our store really. Now we created our store. We have our middleware in there. Just we pass the function literally inside a list. If you go into this middleware parameter, you could see that it is a list of middleware of your state. Okay. So that's really easy. What we're going to do is to create now the body of our scaffold. And this is going to be, I mean, now that we have the store, we have to create a provider for that store as we saw in the previous example. So let's go ahead in the body in here, say we have a store provider, and our store provider has a store of store, and then it has a child. All right. And for the child, let's just say column with empty children for now. Okay. Just like that. Great, and put some columns as well. Great stuff. Okay, so what we're going to do, we're going to go ahead and add our text button in here. So let's go ahead and say the first child of this column, as you saw in this example, it was just load persons. Okay, so let's go ahead and do that. So we're going to go ahead in here and say the first child is actually a text button. Unpressed is going to be an empty function for now, and its child is just going to be a const text called load persons, like that. Okay, then in this function, what we're in this button, we're going to dispatch a message to, or a dispatch an action to our store. So let's go ahead in here and say store dispatch load people action. Just like that's where we're just going to send this action to our store and say, go ahead and do whatever you have to do. And remember, this is handled in two places. One is in our reducer, sets the is loading state to true. And the other one is handled in the middleware, which does the heavy lifting of calling the get persons function. All right, so the button is ready. Now what we're going to do in here is to go ahead and right after this text button, what we want to do is to display a loading indicator, a circular progress indicator, if our store is in loading state. So we have the store provider, but now we actually want to just go into our state, application state, and just grab that is loading property. And remember, for that, we have these store connectors. So let's go ahead right after this text button, say that we have a store connector. Okay, and this store connector works with our application state, but it actually just returns a boolean. Okay, a bool. And then we're going to go in here and say it's. Let me bring up the caption at the bottom of the screen as well, so you know what we're working on. So in here, then what we're going to do is to say here's the converter, and this guy gets the entire store, but we're only interested in a boolean property in that store. So we're just going to say store state is loading. So we grab the boolean value, and then we go into the builder. We say context is loading. So remember, whatever you return from your converter is going to be the property that gets sent to the second parameter of your builder function inside the store connector. Okay. Then we're going to say if is loading, and we're going to return a const circular progress indicator. Circular, if I can type it, circular progress indicator. Otherwise, let's just return a const sized box, just like that. Okay. So this is going to take care of our loading for us. Right after this, what we need to do is to actually create our list, the fetched people that we have. Okay. So let's go ahead and create, right after the store connector, let's create another store connector. And in here, we know that we're working with the state, but when we are working with the list of people, that list of people, remember, it was an iterable of person, but it was an optional iterable. Let's go ahead to the state and just refresh our memories in here. This was an optional iterable of person. So let's copy that type and just say we want to extract this from the store. Okay, so let's go ahead in here and then say that the converter in here takes the store and it reads the store state fetched persons, and then we go into the builder and we say we get the context, and then in here we say people. Now, given this information, people iterable of an optional iterable of person, then we have to return something in here. So let's go ahead and say if people is null, then let's just return a const sized box in here. And to be honest with you, what you could also do, I've put a store connector, or we put a store connector here to display loading indicator. But what you could also do is to say, for instance, if we have a store connector in here, so you could remove this one, store connector that displays a loading indicator, and say, I display a loading indicator in this store connector if people is null. You could do that, but it is a little bit strange, to be honest with you. Displaying loading indicator when the array or iterable of persons is null is not really correct, because maybe this iterable of people will be set to null in some other cases. For instance, remember in the empty state when we went here, the fetched persons is null in that case as well, but is loading is false. So if we do what I just said that we could do, if we do that, then when you land on your application for the absolute first time where the state is empty, you're just going to see a loading indicator. So you're just going to think, oh, something is loading, so I shouldn't do anything. But that would be wrong. And I think that's why we have a store connector for the loading, and that reads the is loading property instead of having a look at the fetched persons. So in this case, when people is null, we just return size box. Okay. Otherwise, we're going to return an expanded, if I can spell, expanded. And in here, for the child of expanded, we're going to say list view builder. And the item count is going to be people.length. Okay. So let's have that. And then we're going to go into its item builder. Okay. Item builder takes the context and an index. In here, let's just go ahead and say, in here, expected to find, okay, excuse me, and a semicolon here as well. Good. In here, we're going to say, final person is, how do we get the person? We get from people element at index. Okay. And given this person, now we have, if you remember, person has a name and an age. So let's just return a list tile for this person. So let's just say return list tile. Okay. And in here, what we're going to do is to say title is a text, text, person, name. And then what we're going to do is to say the subtitle is a text of what we're going to do in here is say person.age years old. Okay. So that's that really. Let's go ahead and do a hot restart in our application. Let's go back to it in here. Let's just make sure that this is our app for sure. So it's not the other app. I'm going to change it to home pages. And yeah, I can see it changing in here. I'm just a little bit paranoid because I have two very similar applications running. I just want to make sure that we're on the right application. So I'm showing you the actual results of the code that we've just written. All right, so we have our button. Let's just press this. And you can see the contents now is being loaded in here exactly as it was expected. So you can go ahead and experiment with this and add like more contents if you want to people JSON. So if I go ahead in here and add another one, let's say Baz, and age is 40, save that and say load persons, you can see now Baz is displayed here. And all of this is really happening with very, very simple functions. So all functions are also separated from each other. So it's, to me, it's absolutely beautiful. Great stuff. Now that we've done that and we're done with this example, let's go ahead as is tradition. Let's go and commit and tag our code. So git add all, okay? And I'm just gonna say git commit step 2, and let's also tag it as step 2. So if we have a look at git log, we have step 1 and step 2. And then let's just have a look at our tags. We have step 1 and step 2. So we could pretty much say that we're done with this example as well. Now that we're done with this example, let's go ahead and have a look at something a little bit more complicated to do with Redux. And in this example, we're going to take it to the next level by creating a reducer that's also able to load not only one asynchronous operation, but multiple asynchronous operations using two middleware. And what this example is going to entail is for us to have two separate middlewares that one loads a JSON file of a list of people and displays the content then and we display the content on the screen. And then we're going to also have separate and individual loading buttons per person on the screen to load their profile picture. So it's going to look like this. I will bring the title, and also I'll bring the iPhone simulator here so you could have a look at it. So if you see here, we have our application. The initial state is with an empty list of people. And what we're going to allow the application or the user to do in this application is to tap this load persons button, upon which we then load a list of people on the screen. But if you notice, every person also has its own state. Every person knows whether he or she's loaded their own image. So each person can have an image, which by default isn't loaded in the application. And then a user can go and say load image, and then that image is loaded for that particular person. So this is, you can also go ahead and load more images for every person. So by this example, we were trying to have a look at how can you have like an empty state of an application where you only have an empty list of people. That's one thing. The second thing that we're going to do is to have a middleware that loads all these people and their data, which is something that we've looked at in the previous example. But we're also going to have the ability to have a state for every individual person themselves as well, whether they've loaded their image or not. So let's go ahead and have a look at how we can fix this. So as you can see at the bottom of the screen, first we need to go to this people JSON file, which is under API people JSON, and we're going to add an identifier to every person. So I've already prepared this, so I'll see if I can grab the contents that I've prepared. So let's go ahead in here. As you can see, I've added ID for every person. So the first person's ID is 1, the second person's 2, and so on. And name and age remain the same as they were before. If you remember here, we had foo, bar, baz. Ages were 20, 30, and 40. So here the ages also and the names are staying the same. However, I've also added image URL. And these images, to be honest with you, they're just random images on the internet that I've found. And we're not going to do anything commercial with this application, so you don't have to obtain any kind of license or anything for using these images. So I understand that by watching this course, it's difficult to, I mean, if you're following along, writing the code as well, so it's probably difficult to read this entire URL because it's just so long. But what I suggest is that you go to Google Images and search for just random person. I literally searched for random person, and I found some images, and I copied their URLs and pasted them in my JSON. So if you want to pause the video now and go ahead and do that, you're more than welcome to do it right now. Okay, so let's go ahead in here. Now that we've done this change in our JSON file, I'm going to close it, and we're going to go ahead into our person class in here, and let's go ahead and add the ID. So I'm just going to say final string ID in here. Okay. And I'm also going to go to my notes just to ensure I'm not giving you any important information. So that's one thing. Then we're going to go ahead and add an image URL field as well to each person. Okay, final string image URL, just like that. So as you saw in the example in here, every person also has their image data. So every person can carry with itself an optional image data. So if that optional image data is null, it means to our application that that person hasn't loaded their image yet. However, if that data is set, meaning that it is not null, then it means that the person's image has been loaded to the screen and we don't have to load it again, for instance. And also, of course, that means if the image data is present in the person class, then we can actually render that image. Okay, if I hot restart the application, you can see this is the initial state, meaning that the person's instances, they don't have their data yet. So let's go ahead and add that image data in here. As you can see at the bottom of the screen in the caption, we're going to go ahead and add a field in here, which is a UINT8 list, an optional, and we're going to call it image data. So this is the way I prefer to hold onto data for an image that is downloaded from the internet. Okay, so after doing that, let's go ahead also and add a flag to our every person indicating whether that person at the moment is loading their image. If you saw in here, if I press this load image for a very quick second, you will, or for a very quick moment, you'll see a little loading indicator. So let's press it. I don't know if you noticed it, but it does display a loading indicator. It's just that I have quite a good internet connection and I can't, I mean, it usually doesn't, it goes so fast that you usually don't see these transactions. But if you're on a little bit of a slower internet connection, you would easily see that loading indicator. So every person is also going to have a loading indicator. So let's go ahead and add a field in here. As you can see at the bottom of the screen, we're going to call it a Boolean field is loading. All right. Okay, now that we've added these, let's go ahead and fix our constructor in here. So we have a required this ID, and then we have three new fields. So let's say required this image URL, required this image data, and also required this is loading. Okay, so we've now fixed our constructor. Okay, let's go ahead and now fix our person from JSON as well. That's an important thing to also fix. And the way to do that is simply by going into basically this implementation at the moment and adding those missing fields. So I'm just going to go ahead in here and make space for ID. And don't worry about the formatting. Dart formatter is going to take care of that for us. So let's just say ID is JSON ID as string. Okay, string. What else do we have? We have name, age, and then after that, we have, of course, the image URL. So let's say image URL is JSON, image underscore URL as a string. And also remember, these two other fields in here, image data and is loading, they're not contents that come from the JSON. They're contents that our application is going to manipulate locally in every person class. But as you also see, our person class is immutable. So how do we actually change its contents? I'll show you soon. We're going to make copies of this class, okay? So let's go ahead in here and we have image URL. And then what we're going to have to do is to go and set image data to null. So if we're instantiating an instance of our person class from JSON, image data should be null by default, and so should is loading also be false. So that's the default implementation for us for person from JSON. Okay. As I mentioned, what we need to do in this application is, if you see on the screen, if I hot restart the application, what we're doing really is when you press this load image, we're going to send an action to our reducer, to our application state, and say, hey, I want to load the image for this person with this identifier. Then what is going to happen is our application is then going to find the URL for the image URL for that person using that person's ID. And then what we will do then is, after loading the image, we are going to actually create a new instance of person by setting its image URL, by setting its image data to the downloaded data. So imagine you have these three persons in the list, 1, 2, 3. Then I say load image for person 1. Then we're going to go off into a middleware in here and download the image. And after the image download is complete, we come back in here, shift this guy out, create a new person, and put that new person in here with the correct image data. So we're going to do a good old shift and replace. So move the old person from the list and then put a new one in there. And also, as you'll soon see, we kind of need, because we're working with iterable in here, we need to have a good ordering of items. Because let's say that you have 1, 2, 3 persons in here, and then you remove the first one, and then you add a new one. This adding is probably going to happen like at the end of the list. So by loading the image of the first person, you are probably messing up the ordering of your persons in the list, meaning that foo is going to disappear from the list completely, and then it's going to be added to the end of the list with its image data. We don't want that. We want the items to be somehow sorted on the screen. And as you'll soon see, I think we're going to use the ID actually to sort these items or persons on the screen, but we'll get there soon. So as I mentioned, we're going to make copies of the current person instance, but we're going to tweak properties. So let's say you have a person instance in here, foo, and then we want to just say, okay, I want everything that foo has, but I want to change its image. And I want to then, by using this in new image data and the old properties of this person, I want to blend them together and create a new person. Okay, so we're going to, for the first time, then write a function in here, and we're going to call it a copied with on this person. So let's go ahead in here and say this function returns a new instance of person, and we call it copied with. Okay, and we're going to have some optional parameters in here. Okay, like this. So a boolean is loading, and then we also want to be able to change this image data just like that. Okay, so this function itself is going to create a new instance of person whose ID is the current instance's ID. Remember, this is an instance function, meaning that it is operating at the moment on the current instance of person. And using that, we want to create a new person. So the ID of the new person should be the ID of the current person. That's what we're saying in here, okay? So let's go ahead and add the properties one at a time. So the name also should be the name of the current person. You remember, we could actually prepend this to these properties, but Dart discourages us from doing that. But just remember, read all these as this.id, this.name, okay? Let's go ahead and set the age as well. After age, we have the image URL, which doesn't change. However, as soon as we get to the image data, what we're going to say is to say, okay, if the given image data as a parameter is actually set to a valid instance of our data, take it. Otherwise, take this image data, you see? And then we're going to say is loading as well should be the given is loading parameter in here, is loading. Otherwise, take this is loading. Okay, so that's our parameter, and then put a comma in there as well. So here we go. We have our new function copied with, and it is optionally setting these is loading and image data properties on our person and returning that person. Actually isn't actually, sorry, I shouldn't say it's setting those properties. What it's doing is creating a new person with these two properties optionally if they exist, if they're passed in here. Otherwise, it takes this properties and sends them back. Okay, now that we've done that, let's go ahead and update the toString function of our person. And in here, let's just blend in the ID as well. So let's just say ID is $ID and then name, age, years old. So the rest can stay the same. This is just, to be honest with you, it's a little bit of a kind of like a poor man's debugging tool as well. If you're printing all the instances of your person class to the debug console, it's also always good to have their ID, because if two people have the same name or same age or both, then it's kind of difficult to see the difference between them. So ID could help. Okay, what we need now is to grab a sorted list of our people in here. So as you can see, we need to get a sorted list of persons, and we're going to go ahead and add this to our state. So if we have a look at our state in here, at the moment it's just it has a constructor, and it also has an empty state. But what we're going to do in here is to actually return a sorted list of fetch persons. So this is an IEEE, it has no built-in sorting mechanism in it. But what we want is, using this fetched persons, we're then going to return a sorted fetched persons in here. And we're just going to use the identifier of these people to do the sorting. So let's go ahead, as the bottom of the screen's caption indicates, let's go ahead and add this function. I'm just going to say iterable person. And this is an optional as well, since it's going to use fetched persons, which itself is optional iterable of person. Okay. And this is a getter, and we're going to call it sorted fetched persons. Excuse me. So what this function is going to do is to say fetched persons to list. Okay, so we create a list out of that. Let's go ahead like this. And then, since toList is also going to have an optional response in here, let's say we are then going to sort this. So fetch persons toList. Let me bring it up here. And then we're going to sort it. We have the person 1 and person 2 in here. And in the sorting, we're going to take the person one's identifier and convert it to integer first. And because you see, the IDs at the moment are string in our JSON, but we're going to make them integers or parse them as integers and then sort them ascending, meaning that ID 1 is going to appear first and ID 2, ID 3, ID 4. And if we create a new person with ID 1 and append it at the end of our iterable, it doesn't still matter. That person will be shifted to the top when we return from the sorted fetch persons, okay? All right, so that's that one. We've created a to list and then an optional in here, and then we're trying to sort it. So let's say int parse in here, and then p1 ID. Let's see what we're getting all these errors from. To be honest with you, I don't see the problem. Let's just go ahead in here and say fetched persons. That seems fine to me. And then to list also works. And then an optional in here, and then double dot sort. Maybe it's now a little bit happier. I don't really know what I did wrong. P1, P2. Then let's go ahead in here and say int parse P1 ID. And then we're going to compare that after this. So compare to int dot parse P2 ID. Okay. And after doing that, we just put a semicolon in here, and as you can see, then the implementation is ready. So now we have a sorted fetched persons getter, which sorts all the fetched persons if they exist using their ID as an integer. Okay. Okay. Now, we haven't really defined any action at the moment for loading individual persons' images. You see, if we go back in here, by pressing this load image, all this button is really doing is going to send an action to our store. It's going to dispatch an action to the store, which then comes to our reducer. And then this guy is just literally going to say, load the image for this person with this ID. So we need an action to define that. So we need an action to say, okay, load the image of a person with a given ID. Let's go ahead and implement that. So let's say immutable class, and we're going to call it load person image action. And this one, of course, extends action as well. Remember, we had action from before, which is like our abstract class here. Okay, so let's go ahead and see if we can find the class that we just wrote in here, load person image action. And this guy is not going to include with itself an entire person instance. It's only going to include the person's ID. Okay, so let's go ahead and say final string person ID. And then I'm going to create a constant constructor for this guy with a required parameter here, like that. All right, so that part's also done. We've defined our action now. So after, do you remember from the previous middleware that we created? We don't have it here because we did it, I think, or do we have a middleware here? Yes, here. You see, when all the persons are loaded from the JSON, the middleware sends an action to the store saying that, hey, I successfully fetched these people. And then the store acts on that and says, okay, in the case of a successful fetch persons, then I create a new state in here where the null error is loading false, and I actually grab the persons out of that action and put them inside the state. We have to do something similar to this for loading individual persons' images. So we have to define an action that the middleware can send to the store saying, hey, I successfully downloaded this given person's image. It's not an action that is triggered by the user. It's, though, an action triggered by a middleware that we're going to soon create. Okay, so as the caption at the bottom of the screen indicates, let's go ahead and add this class in here. So let's say immutable. Let me scroll this a little bit higher. Immutable class successfully loaded person image action. Okay, extends action. And let's go in here and say final string person ID, and also final uint8 list. And let's call it image data. All right. So now that we have these, let's go ahead and create a constructor for this guy. So constant constructor. I like to bring these into two separate lines, and then I'm going to make them both required parameters. Curly brackets in here and curly bracket close. So there we go. Okay, now that we have that class, now this class can basically include the person ID whose image is downloaded successfully and also the image data for that person. Okay, so what we're gonna do is to go ahead in the reducer itself. If we get this load person image action, what we need to do is to basically intercept that action. And the only thing our reducer here is going to do, remember, a reducer can't do and shouldn't do asynchronous operations. A reducer should be a pure function with no side effects. So what is the reducer actually going to do with this load person image action? Well, think about it. As soon as this action comes through, the reducer should produce a new state in which that particular person's is loading property is set to true. So the only thing the state reducer is going to do is to find that person in the iterable of fetch persons if it exists, and if it does exist, it should create a new person instance with the same properties and set is loading property to true and then return a new state. Okay, so let's go ahead and implement that. So we're going to say if and change this to else if, and then in here say if action is load person image action. And remember, then we have to return a new state in here. Okay, so let me bring this else if in here. So let's try to find that person first. So we're just going to say person is old state dot fetched persons. Okay, and then first where, and then let's call this guy P. Then we're going to say we're looking for a person whose ID is equal to action person ID. So that's the person that we're looking for. Okay. And if this person, and because remember, anything can happen in here, we may not even be able to find this person. And also, the important thing to remember is that this fetched persons itself is an optional, meaning that this person is for sure going to be an optional person, even if you think it's there, but the data type is still an optional since the source of the truth is optional. So if persons is not null, and then we put an else in here. If the person is null, which is this case, person is null, then we return the old state. Okay. If we couldn't find the person, then we just return the old state, meaning that nothing changed, the state wasn't modified. However, if we did find the person, let's just return a new state in here. And then we're going to say the error is the old state's error. So we don't modify the error in the new state. Is loading, we say false, okay? Because if you're loading the image of particular person, you should set the is loading flag of that particular person. Remember, this is loading flag is used to indicate that we're actually loading the entire JSON of persons. And in the case of loading the image of a particular person, the JSON has already been downloaded, so we don't have to do anything special with that is loading flag. Instead, we should just set it to false. Now, with the fetched persons in here, this is the exciting part. We're going to go ahead and take the old state's fetched persons, okay? And then we're going to find that person basically in here. So we're just going to say where. So what we need to do really in this statement in here is to kind of remove that person with that ID, and then add a new person copied from this one. Okay, so we're just going to do an old shift and replace. So in here, we're going to say take all the persons in here as long as their ID is not equal to this person ID. Okay, do you get it? So let me bring it to different lines in here. Okay. So as long as, so we take the old states fetched persons and we only keep the persons whose ID is not the current person whose is loading flag we're going to change. Okay, so this is a little bit of a strange way basically, but it's the easiest way of going about doing this. Then after doing that, we're gonna say followed by. So this is an iterable of all the fetch persons, excluding this person. But then we're gonna add that person, and we're gonna say person copied with, and then we're gonna set the is loading flag. You see, it's the first parameter to true. So I want you to pause the video in here and have a look at this code a little bit. So take the currently fetched persons, remove the current person from it, and then add the person again, but by setting is loading flag to true. And remember, this returns a whole new instance of person. Okay, this is the function that we wrote earlier. Okay, so that part is done now. So we can go ahead and move on to the next item. And great. Now that we're done with this, let's go ahead and handle the successful loading of a person's image. Remember, we have defined this state in here or action in here, successfully loaded person image action. So we need to handle this also as well in our reducer, because this is not the job of our sending of this action is the job of our new middleware that we haven't created yet. However, accepting this action and actually setting the image data of that person is the job of our reducer. So let's go ahead and handle this. So in your reducer, go ahead and say if action is successfully loaded person image action, and then let's put an else in here. Okay. So we're going to do actually something very similar in here in this case that we did here. And this is simply because we need to find, in this case, we need to find a person, and then we're going to remove every other person from the list, and then follow it by the new person with the copied with, and then we're going to set the image data. So I suggest that you go ahead and copy this code that we wrote in here, copy the entire code for load person image action. As you can see in here, I've copied that all. Then I'm going to paste it in here. Okay. And then let Dart Formatter do its formatting. Then I'm going to go in here and only change one thing in here. I'm going to set this is loading to false, and the image data is going to be the actions image data. Okay, so that's it really. We're creating a new person instance whose is loading flag is false, and also the actions image data is replacing that old person's image data. Okay, so what we did is basically, yes, we handled the successfully loaded. So I should have brought this caption a little bit earlier. So let's go ahead and write now our reducer for handling this load person image action. And this reduce, oh, sorry, not the reducer, but the middleware. And this is an example of a middleware that we've written before, load people middleware. And our new middleware is going to have to have the exact same uh, function signature. So I'm going to copy this in here, okay? And I'm going to go here and then paste it one more time. And then we're going to close the curly brackets, and let's call this load person image instead. Load person image middleware. So in this middleware, our job is to load a given person's image. Okay. Don't forget to call next in here, because this is our next dispatcher. So we say next action. This is the first thing you should always be doing in your Redux middleware. Call the next reducer. Sorry, call the next middleware. And what we're going to do in here is to find first. So if we're going to say if action is load person image action here. Okay. Then we're going to find that person. So since we've already done this before, I'm not going to write the code again. I'm just going to paste it in here to make it a little bit easier for us. Let's see if I can get the code formatting a little bit better. Maybe this is the best we can get. So you can see in here, we're saying person, and we first need to find the person given this action. If you go back to this action, it includes the person ID. Okay. So let's go back to our middleware. So we say, okay, we have the store. In the store, there's a state. In there is a fetched persons. And in there, we can get all the fetched persons. We're looking for a person whose ID is the same as this action's person ID. The result of this is an iterable. However, we're only interested in the first instance of that. Actually, I don't know if there's a first where. First. Yeah, there's a first where. That's interesting. Maybe we could use first where instead of this. So let's say first where, and then remove this first. So this person should now be an optional person. Let's see. Yeah, great. First where actually works better than saying where first. Okay. Now that we've done that, we need to go ahead and say, okay, if this person does exist, so we say if If person is not null, what we need to do is to construct a URL for this person's image downloading. So let's say final URL is person image URL, okay? And then we're going to say final bundle is network assets bundle, boom. And we get the URL in here, okay? And we have to actually say URI parse URL, I believe, because this expects a URI, okay? After we have that, we say bundle, and then we load the URL just like this, and then we say then, and then what we're going to get in here is actually the data. So you can see it's the byte data. So I'm going to call it BD in here. And then what we're going to do inside this, when we get the byte data, let's say byte data buffer as UINT 8 list. So that's that one. That's that then statement. Let's see if we can bring it up a little bit, just like that. Okay. After doing that, so the result of this guy is going to be, if you look at value, it's going to be data for us in here, which is the image data. Okay. So in here, what we need to do is when we get the data, let's rename it to data. What we need then is to dispatch, we go to the store and we say dispatch. We now need to tell the store that, hey, given this person ID, we got its image data. So for that, we have an action successfully loaded person image action. The person ID is person ID, and its data is this data. And then put a semicolon there, put a semicolon here, and I believe that's that. So I want you to pause this video, please, and have a look at the code. So what we did in here, if we could find a person, then we're getting that person's image URL. We're creating a network asset bundle with that URL. Then we're loading that URL. And then when we get the byte data, we're converting it to its UINT8 list, which is what our person instance expects. After we get that data, as you can see, it's a UINT8 list, then we're dispatching this action to our store saying that, hey, we successfully downloaded this person's image. So let me put a semicolon in here to get the formatting better a little bit. Okay, and as you've seen, just for the sake of simplicity, we're not handling errors. I mean, because if you're handling errors, then you also have to go and have an error object in every person. Then you also have to have like a error action to handle. And since we've already handled errors in the previous examples, I thought to leave it out of this particular example just for the sake of shortening this video a little bit as well, so we don't have to over explain everything. But you should know how to handle errors simply by doing a catch error at the end of your future. All right, now that we've done this, we have this middleware, so we should not forget to add that middleware to our store. So let's go ahead and after the load people middleware, add our new middleware as well, just like that. So now we have both middlewares in there. So what we need to do is to go ahead and grab the current subtitle and name it info widget. Okay, so let's go ahead and somewhere in here, let's see where we can actually add the info widget. So perhaps we could go to our list view here, okay, in here. And let's go ahead, now we have the person, let's go ahead and add an info widget because let's see if I can bring it up, the example in here. So the info widget, as you can see here, is 20 years old. So we're gonna basically put that inside its own widget just to clean this code up a little bit, okay? So let's say final, and let me see if I can copy paste a little bit here because it makes it easier as well for all of us. So we have this info widget, which is the text. It's the exact same thing as we had here for the subtitle. So, and you'll soon see, we're just gonna make the code a little bit cleaner to use, okay? So what we're going to do is to replace kind of, if you look at the execution of this, we have 20 years old in here. It says food 20 years old. And if I press this load image, you see what happens? It says food 20 years old and then the image, because this content is going to be placed inside a column. So if this person's image hasn't been downloaded, then we displayed this a column only with this 30 years old info widget in there. Otherwise, when you press the load image, then we're going to put a column with this info widget in there and then the image right after. Okay, and that's why we have this info widget separated here. Okay, now we're going to go and calculate this subtitle. So let's go ahead, final subtitle. It's a widget subtitle. And we're going to say if the person's image data is null, then the subtitle should be the info widget. So I'm going to bring it here. Then it should be the info widget. And otherwise, it should actually be a column. So a column with children, the first child of which is going to be info widget. And let's actually set the cross-axis alignment to also start, cross-axis alignment start, just like that. And it should be the info widget. And then now it's the exciting part, because here we're going to then display the image for that person, okay? And we also check person image data. If it's null, then do this. Otherwise, when we come here, we should be sure that the person's image data is actually non-null, meaning that it does contain some data, all right? So in here, we're just going to say image memory, and then we're going to take the person's image data, and then we're going to put an asterisk in here to force unwrap it, okay? Great stuff, because you see, you can't do this because the data needs to be present. This memory function doesn't accept optional UINT8 list, and that kind of makes sense. If you want to display an image, you have to have its data. Great stuff. Now that we have that, we also have to go and calculate the trailing part of this. If I hot restart this application, let's go in here. And if I say load persons, while this loading is happening, this load image button will be changed to a circular progress indicator. And if I press it now, you saw it for just a very, very short period of time, but it does work. So what we're going to do now is to, based on the is loading property of every person, we're going to construct a widget that we call trailing. And this trailing widget should be set to this text button if the image isn't present, if is loading property of that person is false, we should display the button. If the is loading property is true, we should display a circular progress indicator. Okay, so let's go ahead and take care of that right now. So let's say trailing. So we're going to say final widget trailing, and that's equal to if person is loading, then we're going to say, let me bring this down as well. Then we're going to say const circular progress indicator. Okay, otherwise, we're going to create a text button. And that text button is literally going to be our load image text button. So text button here, and we need onPressed, and then we also need a child, which is going to be a const text load image, just like that, load image. All right, boom. And a colon in here to get the formatting working. And for onPressed, we're going to dispatch a message to our store. So I'm just going to paste that code so I don't have to write everything. And as you can see here, we're dispatching a load person image action to our store, which is handled by both the reducer, remember, setting the is loading property of the person to true, and it's also handled by our middleware. So we can go ahead and have a look at it actually for just a refresher. So here it is handled in the reducer, and it's setting the is loading flag of the person, and it's also handled in the load person image middleware. Of course, it's dispatched here to the store using this trailing text button. Okay, so let's go ahead and update this list tile with these new properties. We're going to keep the title the same. However, the subtitle, we're going to change to subtitle in here, and trailing is going to be trailing, just like that. All right, so these are the properties that we've just created. So what I'm going to do in here is I'm going to stop the execution of the other program, and instead I'm going to execute this new application that we've written here. I don't want to have two apps executing at the same time. So, I mean, what you could do, to be honest with you, is to have a quick look at the code that you've written, also consolidate with the code that I have in here, just to make sure that you've done everything correctly. And if you need it, I can actually share this code as well on GitHub if you're stuck anywhere. So let's remove this, and let's go to our simulator in here, and we have load persons. And I'm going to press that button, and you can see then our persons are loaded on the screen. Then I'm going to press the load image button of every person. And I can see in here, we're using bar BASFU, and this is a great example because we forgot something. Let's hot restart this. I'll show you what is happening. Load persons. Foo is right here, okay? And we're saying load image. Remember what we did in load image? We actually remove that person from the fetched person's iterable, and we create a whole new person instance, and we place that person instance with its is loading property set to true in the resulting states fetched persons. What happens in there is that this person will then get appended to the end of the iterable with its new properties. So see what happens in here. And then foo jumps out of its current place and it goes to the end of the iterable. Look, did you see that? Then foo is here. So we're just messing up the order of our list basically. And we don't want that to happen. So what we need to do is not to use fetched persons in here. Instead, we need to use that new property that we have, which is called sorted fetched persons. Okay, I'm going to save this file. I'm going to actually hot restart the application. So let's say load persons. And then if I say foo in here, you can see foo stays where it was because uh, stored fetch persons it's sorting the entire iterable using the IDs, and the ID of foo is 1, so 1 is always going to stay on top. Then bar is loaded, it stays at the same place, and baz the same. So that's really it. And yeah, I should have brought this caption up. So it does work. We don't have to demonstrate it again, to be honest with you. Load persons and then bar, foo, and baz. Okay, so that's another example of, actually, this is the last example of this chapter, and it showed how we can use multiple middleware and how we can contain state in both the application state and also inside the models that this state contains, the fetched persons. Okay, as is tradition, let's go ahead and commit our code. So let's go into terminal and git add all, and then let's say git commit step 3. And git tag step 3 as well. So if I say git log, now we have all our steps, and then git tag also we have all our tags in there. So we've learned a lot in this chapter, but if you really want to wrap things up, you need to always, when you're doing Redux and Flutter, or if you're doing Redux anywhere, even if it's Swift or Rust or Django or whatever you're doing Redux in, you need to keep always the state in your head. You need to know, okay, how do I have to define state in my application? How do I need to define my reducers? What are these reducers going to do? What are my actions? And try to keep things pure. And by pure, I literally mean your reducers should be pure, for instance. So they shouldn't modify anything as a side effect. They should take the current state or the old state, and they should take an action and then do something with that action. No side effects, no loading and fetching stuff on the background. That's the job of the middleware. So they should take those actions and then change the state optionally and return the new state. Or if they can't do that, they should return the old state. So that's for the reducers. And then you have the middleware, which they're able to execute side effects and go and do some work asynchronously. Middlewares are not marked as async functions. And then they are simply using Dart's internal and built-in support for futures. So always keep those things in mind and practice, because just watching this video is not going to help that much. You need to like pause the video, go and do the same thing and write the same code that I've done, and you'll eventually get it. So I hope really that you enjoyed this chapter. I had a lot of fun making this chapter for you as well. I think it's now about 3 hours I've been talking. So I hope that you could get some value from this chapter. And if you have any questions, please do let me know. So I hope to see you in the next chapter.